Hello. Yes, Ananya, I can see you. Yeah, can you hear?
Yeah. Hi.
Wonderful. Again, thank you for agreeing to the new schedule. Yeah. If it is giving you some trouble, please tell me. Okay.
Yeah, okay. I think it's okay.
What do you think? Shall we kind of do and make sure the mind map is okay first?
Okay, sure.
Uh, there will be a sign that you have digested this part of the slides, lah. Right. That's what we're aiming for.
Yeah.
But hopefully, it takes only half of today's lesson. Hopefully, yeah.
And
Okay.
my phone is like that.
Yes, Tristan, you're
My
saying?
phone is out of battery. I need to give it a while to charge.
Yep. Yep. So it's kind of normal. We kind of tend to forget about this thing at first. Lah. After a while, you get used to it, right? So you don't
Okay.
worry about that. So now, Tristan, we're doing a verbal update first. Lah. So tell me what's happening last week. Did anything happen?
Last week of school.
As in last week, you should have two no school days, right? On Thursday and Friday, lah. So that one, and then what
Friday
happened to the trip?
Friday I had school.
Oh, Friday as well. Okay, so then tell me what happens in that week, lah. As in, just limited to your science first.
Yes, science we just I think we just summarize the whole of the last topic. Then now we're moving on. Next week, then we'll move on to the.
Okay, all right. So very roughly in physics, are you finished with pressure or not?
Yeah, pressure as in what?
Yes, pressure as in the chap.
Wait, like the force, that one, right?
Pressure times area equals to force.
Oh, that one. Yeah, that one.
Yeah. Okay, that one done. Okay, then anything else beyond that?
I think now my teacher is teaching about the what's that? About like the energy.
The energy, all right.
Like
right.
the gravitational
one
converted to the kinetic, I think. Yeah.
Right. In this one, you remind me if I remember correctly, but were you there when I talked about it during holiday?
I don't think so.
I don't think so. Yeah, because we only meet twice now, so we didn't cover much. Understand?
I think you can do that today.
Yeah. And so noted on that. And then chemistry, what?
Chemistry, my teacher didn't do much this week. She just went through some RO topics, like finish up.
So where are you exactly?
Haven't started on the new one yet.
So let me confirm that you haven't touched anything on mole.
Nope.
Acid and base.
Not yet.
And if acid and base no, then solubility no lah. Then QA lo, QA. No also.
No, I don't think so.
Understood. A little bit uncertain about the speed lah, but we'll see lah. We'll see what happens lah. We'll see what your teacher do.
All right.
Okay. So for today, I'm in the Jamboard already. So at this point, yeah, you don't have any homework, isn't it?
No, I don't have any. No.
Can I take a risk? Okay, let me explain roughly what will happen in the future. Yeah. So in the near future for chemistry lah. Sorry, physics first. Physics is very easy. Physics upcoming topic. This energy work power one is not very complicated. Partly because you're already doing that from primary 5. I mean, but there are some new things. Now the new things are not that complicated. So this chapter is not supposed to be a very hard one, right?
Yep.
If we end up not paying attention to it, that's the reason. No? That means we just rely more on what your teacher talk about in the homework, and we discuss the more difficult question. That's just standard.
Okay.
So the chapter after that is slightly more difficult, but also not the most difficult. Same thing. some
Alright.
discussions and good practice, we should be okay for physics. That's not a
Okay.
surprise because physics is entering that kind of period before it gets hard. So these two chapters will be supposedly easier to understand, and we have to make use of it because those two chapters definitely will some question will come out. So I'm not saying that we should abandon. I'm saying that it's a good time to just make sure that we understand. Okay, that's it again for two chapters. Remember, two chapters. For chemistry, it's different. From now on, no matter what chapter you learn, it will be important. You cannot
Yep.
afford not to. Okay. So back then I told you that okay, we gotta start. So chemistry start like this. No? So the concept you cannot not understand. You have to. The memorization you also cannot. So these two things makes it difficult because some people will just memorize without understanding.
Yeah.
Some people will try to understand and the memorization is not easy, right? Now, I take it that your memorization is okay.
It's not bad, yeah.
Not bad. So we clear that first. Then it is much easier for me to just jump into the question and show you what's going on. If you don't have the memorization, you have to bring back, then you feel that, hey, maybe I don't know this. Yeah, but it's just memorization. Something like that. Okay. So if today you're fresh, we do that. Okay. Yeah. Now you go to page 6.
Of the Jamboard, right?
The trial Jamboard. Yeah. Okay. So Ananya, tell me, what are you doing right now?
I actually did 3 papers the past 2 days because my exam's on Tuesday and I have a few questions.
Right. If that's what you want to talk about, that's totally fine. Could you please put them in the Jamboard?
Okay.
Keiko, just to confirm, nothing new yet, right?
No, okay, I did manage to do another paper 1 for math.
Good. That's what we need. Right?
Conceptually, it's really okay. It's really just the manipulation at this point.
Which is what you said, right?
Yeah. And I noticed I struggle particularly with integration involving trigo.
That is not easy if you want to discuss about it a little bit. Yeah. But there isn't a lot that we can do right now. But we can talk about it at least, because I've never seen you do it. This is new to me, your weakness here. Right? Okay. If you want to talk about it, that's fine. But we should accept the fact that this is the weakness for this exam.
Okay.
So now for you, Tristan, in page 6, I gave you the first memorization. It is not very complicated. Okay. This is the acid-base list. I'm giving you 1 minute to look at it and then do it on paper and then just send it to me. Okay. Just 1 minute. That's our startup today. Yeah? Okay, good. Okay, so for Ananya, I think you're trying a few stuff, right? Okay. Do you want to ask the Feynman thingy?
Yeah, I do.
Okay, just a minute. My drawing update. Right. Okay. So, feel free to refer to the slides, but you know the X is 18, right? You know it's X 18, and this is a neutrino, neutrino something we have to find out a little bit, right? But do you understand why he started with UDU?
No.
So he does not start with K, right? It's weird, right? Correct. It's weird. But this is totally what your slide talks about. Believe it or not, your slide is useful. Your slide is useful. It's just slightly harder to understand. So this is a proton changing to a neutron. How do we know? This is 19 proton. This is 18 proton. 1 proton is gone. But the nucleon stays the same, right? So neutron here 22. See, a proton changing to a neutron. This is totally what your slide is talking about. if you don't get what I'm saying, you better look at your slide. This is now time for your slide to finally shine, right? Yes. Yeah. Again, if you don't know what I'm talking about, you better ask me, or like which slide are we talking about or something like that.
Like at the proton theory.
That is definitely in the last few slides.
Okay, I'll
Last
go
few
check it
slides.
later.
Yes, please. Kristen, are you okay? So,
Yeah, I'm trying to memorize the thing.
okay, so you're writing, and then before you send me, check the Jamboard using a different color. You correct
Oh,
yourself.
okay, yeah,
Right?
sure.
Correct yourself. That's the normal way of memorizing. Right? That's the very fast way of memorizing. Right? After you get used to it.
Wait, it's the one on page 6, right?
It is on the basic, which is a rather short list, I would say.
Okay.
Keep on just waiting for it to load. Yeah.
Mm.
You okay, Anand? Are you having trouble finding it?
Yeah, I'm finding this.
If I have your slides, so I'm gonna want you something. You're on Tom's slide. You can erase that slide.
Okay.
Okay. At slide 129.
Yeah, I'm looking at that.
129 and compare it 131. 129 and 131. Right? If this doesn't make sense, better tell me. I was assuming that we get it last time. Right? So finally, Keiko, why are you redoing, Keiko?
And this is a
You
new
want to
one.
show me.
No,
This
this
is
a new
a
one.
it's a new one. Oh, you're trying to just practice this, lah. Okay, I understand.
I guess.
Mhm.
This one is not as complicated as the one I did though.
Mm. That is goodness me, that's very easy. No, where's the one is gone? Like no, this is easy, man.
Yeah.
No, this you did it fine. You did it well. Right. Okay, no worries. Right. Not sure whether B will be challenging, but if you recognize that, that's not a trigo problem, right? For example, yeah, you do what you want. You do what you want for now. Tristan, okay.
Why does it change from a proton to a neutron?
So again, if you look at the your Jamboard, right? The Jamboard, let's agree first that we are concentrated on K and AR. Let's agree on that first. Okay, the photon number is 90. The argon proton number is 18. One proton is gone. It cannot just be gone. In this case, we now say it might be changing. Maybe, the neutron number is 21, becoming 22. So a neutron suddenly appeared. And we say, no. There's no such thing as suddenly appearing. This is more likely a proton changing to a neutron. Okay, but the beta and the neutrino follows that. I mean, for whatever reason we'll talk about later, it's actually very important that they are in. A proton cannot just change to a neutron. That also doesn't work. If you simplify it further, it's just a U changing to a D. Am I making any sense right now?
Okay.
A proton is UDU. For whatever reason, we memorize that. A neutron is UDD. For whatever reason, we memorize that. If you look at it, oh, that's just a U inside the proton changing to a D. Therefore, proton becomes neutron. That is the simplest thing you can say for it. However, it's not just that. It will be U becomes D, and then with an electron and then a neutrino, which is very nicely what page, in this case, page 131 talk about it. Definitely, that's what 131 talk about. Exactly what 131 is talking about. So the answer is exactly 131. This is a very standard thing. This change is a super standard thing. That's why I chase it until this slide.
Okay.
Back then, I was waiting until this slide to appear. There you go. We should talk about this. Now, you can copy it, of course, but you better try to at least understand it.
Yeah, I do understand.
If you do understand, then remember this as a likely thing, I suppose.
Okay. So every time there's a beta plus decay and they ask me to draw a Feynman diagram, it's probably like this.
I would argue that you should at least confirm it is a proton changing to a neutron. But I'll argue that.
Okay.
It can be neutron changing to proton also. It can be like that's page 129. Right, just a reminder.
Okay. Also for beta plus, the notation is like 0, 1, right?
Definitely. So it's like an electron but plasma. Because a beta is supposed to be an electron, which is a negative lah.
Yeah. So beta minus would still be 0, minus 1.
0, minus 1, definitely.
Okay.
So Tristan, I see. So you got the shy one, you forget that one, and this is totally fine. Okay, Tristan, this is your first memorization. Okay, so far so good, yeah? Tristan?
Yeah.
So don't need to turn on your video first because this is more and more memorization. There will be 5 groups.
Okay.
Whenever you feel tired, you tell me.
Wait, what do you mean?
Because I will ask you to memorize more and then more and then more and then more until we're done.
So today just mostly memorizing lah.
I was hoping for only 1 hour, but to be fair, we cannot do much without this. Just to be fair. The other side is if you know this already, it's rather easy to just do the question. It's almost as if it's just like that one. Of course, it's not true, but it's almost as if. So, I mean, we are already trying to do something faster than the class. So that is already a good thing, right? That's what a good student do. You just try to understand what's going on. Okay. Yeah. But so happens you have to memorize this. So I might as well just ask you to memorize that. Might as well.
Okay. Yeah, sure.
Right. So again, if you're too tired, you must tell me.
Okay. I'll tell you.
So page 7, that's what you memorize. Okay. I'll give you 5 minutes and then you run. Okay.
Okay.
Don't try to be perfect. Just try to do the best.
Yep.
Okay, Keiko. At this point, that is not going to be difficult, right, people? Yep. And can you you can do that, I guess. Which I guess you would like to integrate a cosecant square. If that's what you want, that's fine. That's actually that's fine. That's fine. What you're doing is fine. Actually, that's fine. Okay. Okay. Ananya, are you okay so far?
Yeah, wait. I'm pasting the answer. Okay, just let me check if it's okay.
Sure, you're pasting something. Sure, I think. So I'm just reminding you that it's like, again, I'm trying to rehabilitate your slides reputation. It hasn't been good. It hasn't been good. But I'm really trying to say that your slide actually talks about the important things. It's just that this, I mean, whatever, the subject matter is abstract. You need to write the W plus boson.
Oh, right. Okay.
Yeah, because if you don't understand that, you tell me, right?
W prime. I think you explained it last time.
Yeah, try to rehabilitate your slide. But if not, we just rely. Okay, sorry, we just rely on there's a table that you will be given anyway, right? What is that
Yeah.
table? I was actually trying to. You should be looking at it right now, right?
I have it.
Yeah. It would be nice because I mean, if you're doing this, might as well get used to the table you have in Excel, right?
Maybe I'll paste it into the Jamboard.
Did I? I hope. Yes. No. Large Jamboard. If you can look at it and paste it here. If you're still doing this kind of question. Right? Okay. So that is what we need. That kind of explains everything. Right? Yeah, looks good to me. Wait, what?
Wait,
Sorry, Kristen first, you're saying?
this this one did we do? I think we did this before, but I think I can re-memorize again.
I think so. I think so. We go through like almost half. So
okay.
if you're confident, close it and do it.
Okay, I'll do
even
that.
better. Even better.
Okay.
Yes, Ananya, good. Yes, those things. Things. He doesn't tell you about the dark. So the W minus is deduced. Is deduced. How do we deduce it? So U and D, right? The difference is this is 2 over 3e charge, right? And this is minus 1 over 3e charge, right? Okay. So there is a -1 charge going on. Does this make sense, Ananya? I'm using the table purely.
Yeah, it's okay.
So how did a -1 charge, happen? It doesn't just happen like that. It must be a W negative boson, being W positive boson. The positive simply means that the boson is going to carry a positive charge. So this is like releasing a positive charge. So my charge will be -1. It's really a simple thing. It's not something very complicated, even though we cannot imagine how that works. Am I making any sense right now?
Okay.
Right, again, my bank account -$1. I must have given +$1 to somebody else. My wallet, -$10. I must have given +$10 to somebody else. So later on, this W plus boson cannot stay boson. It will become something else. In this case, it will be an electron positive, your beta plus. and a neutrino, which is not a neutral. I'm sorry, neutral.
Okay.
Are you sure you're okay?
I think so. Yeah.
And let's move on to the next question.
Mm,
Okay, Keiko, I was following your work, right?
It felt a bit long-winded though.
It's okay for 5 marks. I'm not sure whether there's a faster way, but I don't see any problem right now.
Mm,
For 5 marks, this is like acceptable and your tempo is acceptable. Again, let me repeat this. Integration can never be fast one. Like you don't expect A part 1 to happen all the time. Considering what I will expect of myself, this is a reasonable tempo and a reasonable answer because you're correct. Like you get the 5 marks at this point, right? And it is not a trigo problem, so to speak, I suppose, because it's easy, like the trigo becomes easy, right?
Okay, wait, the one I did. You know.
Kristen, are you writing and checking?
Yeah, I'm writing the last part.
Sure thing.
Yeah, these are the two questions in the paper that I did that I couldn't do.
So that is, yeah, okay. So the cosine 4 1, you have to make some guesses. That's not easy. So it is very likely that you have to use a combination of the trigo stuff, right? Plus the partial, what do you call it?
Actual question.
Integration by parts, or integration by parts.
Oh,
I mean, that's probably how I will start. I probably won't start with substitution because the rule is in general, the exam won't give you a substitution question hidden. They will tell you one. They will tell you at least if you need a substitution. And most of the time they tell you what the substitution is. So that's more like I'm not sure whether it's agreed in the syllabus, but it's a nice manner, I suppose. It makes it a lot easier. So do you want me to try to do this? I'll have to do some guesses. If you want to, Keiko, we should move to the bigger part, right? We need a lot of space. Okay. I would suggest by parts, and I'll suggest starting from cube and single. Let me think. Is that what I'm suggesting? Wait. Actually, no. Okay, Ananya, I see your next question here. So what do you have for me there?
It's basically the ones I highlighted. So like, how do you calculate total average kinetic energy?
All right. Okay. So we answer that first. Okay, cool. Nice. Okay, so actually that's, as the 1 mark suggests, that's not the hardest. So you already have for one particle, right?
Sorry?
Does that make sense? Part 3 is for one particle. I wrote something. If you cannot see it, that's iPad doing its stuff. Go in and go out.
Oh yeah, okay, sorry. Yeah,
So
this for one particle.
So that means total is for all particles, which basically means you just have to know how many particles there is. Okay, and our math kind of gives you the hint, right? You can find out. Oh, I'm sorry, two more is our key here. So Gonna jump here. So 2 mole is equals to 2 times 6.02 times 10 to the power 33 particles. In this case, gas. Do you know this number? It's
So
magically
Avogadro.
appearing number. Yes, the Avogadro number is the number to tell you what a mole is. A mole is a very big number. Here you go.
Okay.
Just using that, you can times the thing later. Hope that makes sense.
Wait,
This is standard.
Then I divide
Yes.
by.
Oh no, times. This times the particle.
Oh, so that's it. Okay, okay.
Does that make sense? Okay,
Yeah,
this needs to make
okay.
sense. Yes, Tristan. Okay, Tristan, you're saying?
For my like the one I sent you, right? I'm not sure what is like after aqueous acidified potassium. What's the last thing?
I'm gonna copy it. Right?
What's
Settle
the
it.
manganate?
Oh, you mean the sulfur dioxide one?
Yeah, what's that manganate thing?
Okay, that's new. You
Yeah.
have to memorize, but if it helps, I'll give you the chemical formula. I'm not sure whether that helps. But
Okay.
Potassium MnO4. There you go. I mean, it's something. It's something that tends to be standard after this. Maybe this is just the first time you encounter. The
Oh.
color is also kind of standard. Purple to colorless is a nice thing to know.
Whoa.
Right.
Okay.
So from now on, I keep saying it's just memorization. It's just memorization. But hopefully, when you use it, then there'll be some understanding coming.
Yep.
Okay. Right.
Okay.
Yeah, that's good. You know, almost perfect. Perfect or not doesn't matter. You're familiar now. The anion. I think you're at this point. Like that.
Oh, this anion, I think this will take a bit longer.
Yeah, but at most 7 minutes. I'll give you 7 minutes. Then you just stop.
Okay.
Okay, so Keiko, I'm just trying a few stuff. Right? Usually, I will just try stuff in my mind immediately. Lah. Okay. Oh, I don't like this. I don't like it. So I was thinking about it, and I don't know, but I don't like it immediately. That means, Keiko, I'm trying to chase after something, right? I cannot fully explain it. I don't like this also. You know, so I don't like this. What do I do? So my bet is to try this by parts first. Now, have you tried that, Keiko? I didn't know what you tried. Like.
Okay. I think this is wait. I didn't write anything on the paper. Okay,
Right.
at first, I only wrote this down on my paper. I didn't. I didn't include the 4. So I think that's.
Yeah. I'll try this as by part puzzle and see how what happens. That means at this point, my feeling is telling me I should go step by step and evaluate. And which means I'm going to do this at the end one, unless I know where I'm going. The problem is I don't know where I'm going. So I'm going to do it at the end. I'm going to go slow and I'm going to evaluate per steps, and I'm going to prepare a lot of options. That is the situation that I think I'm in. How many marks is it? If it's a 3 marks, then I'm over careful.
It was part of a graph question. Like it's area under the curve or something.
It's part of Are you sure you cannot just do, if it's area under the graph, why don't you just do a definite integral by your calculator?
It's exact.
Not sure lah. So currently I'm in a not sure situation. So Ananya, are you okay?
Yeah. Also, there's the part 5. Part six.
Sorry, part 6. Sorry, I kind of missed part 6. I'm sorry, Ananya. While you're waiting for me, are you doing something else? Sometimes it happens like waiting time.
Yeah, I was reading the other questions that I need to ask you.
Wonderful. Right. So as long as you're not waiting for me and doing. Okay. So name of the condition is okay. So I'm not sure whether this is in your slide, but I can tell you a few things. So a real gas, the particles will have a certain volume, right? An ideal gas, they are assumed to have no volume. This is important because a real gas means the particle will bounce around very differently from an ideal gas, which is assumed to be no volume at all. It's just a point. Okay. So this is how real gas differ from ideal gas. I haven't answered the question. Am I making any sense right now?
Yeah.
So therefore, I want to be able to ignore, so to speak, the volume of the real gas. Not the volume of the total gas, but the volume of the particles. Okay? That is what I'm trying to do when I approximate an ideal gas. I want to ignore the volume, which is actually present, of the particles. Am I making any sense? So far. If I can ignore it, then I can pretend there is no volume, right? Ignore. How can I ignore it? When the gas is not very dense. When the gas is, just nicely like that. And here's a comparison of a denser gas. A denser gas is because it's high pressure. This is low pressure. When my gas is low pressure, I have less particles flying, so I can ignore it more easily, the volume of the particles. When I have higher pressure gas, I have more particles, and suddenly I cannot ignore it very easily already. This is one of the conditions. When a real gas approximate, not making any sense, right?
So it's basically low pressure or low density.
Yeah, you cannot say density. When I say density, I mean because we understand more, right? But the proper thing is that it's low pressure. Low pressure is less particle, which is what I mean by lower density. But please don't use that phrase to refer to gas. You just use lower pressure. When a real gas has low pressure, it will approximate ideal gas. That's the condition. There are other conditions, but this is the easiest one to understand. Now, is this in the slide?
Maybe towards the end. I'm not too sure. I didn't notice it when I was looking through.
This is probably more towards the middle or the first part. Usually, I'm not sure. Depends on this. But if you understand this, just know that they kind of like to ask them. Kind of.
Okay. Okay.
So, Keiko, I'm just following your work. Right? Oh, you buy parts twice already. Am I correct, Keiko? Oh,
Yeah.
And you solved the problem. No, I was, yeah. So this works, I suppose. Not sure how this will help later, but this seems to work, right?
I guess.
You did not remember what you tried.
I didn't write down anything for this question.
Mm-hmm.
Yeah, I may have skipped it while I was doing this.
But I'm not surprised that by parts work, but I'm also not the fan lah, because everything by part is usually very tedious one. Usually, meaning we have to be very careful if careless mistake. That's my concern. I don't mind the long work. It's the after long work still wrong some more. That's the part where I really don't like something like that. But that's the risk we take lah. And that's why we do this at the end, no matter what lah. No matter what. I hope you're quite okay.
I think so.
For the third one, I'm not sure. I would probably do something similar at the start. Oh, Ananya, you have a new one.
This last one.
I'll probably do this and this is going to be the default. Never mind. Start like this first, but I don't think it's by parts lucky. I don't think so. If you could do something else, that's better. Kristen, are you okay so far?
Yeah, I'm still doing writing right now.
Writing, very good. Yeah.
I think I'm a bit confused about the last part. Like, I don't really understand what I'm doing also.
So let's just say that so far what you're doing in the delta M is correct, right? Definitely. Yeah. And you minus the individual with the total, right? The combined one, sorry, the combined one. And you will find that the individual has a higher mass than the combined in the form of CO, which is always the case, because when they combine, they become thinner, right? They go on diet, so to speak, right? So that's your delta M, and then you're very close, right? You just have to change the delta M into a energy in terms of, no, it's MEV. So you want MEV, not joule. So I think it's actually easier, right? So I want you to refer to your data booklet, what you will have in exam, and you have a number that you're supposed to use there. If it is changing from U to MEV, this is like not a complicated thing at all. If you don't know what you're supposed to use in the data booklet, that's not good. Okay, I'll give you 1 or 2 minutes. If you don't know which one, I'll show you. Just tell me.
91.5. Is it?
931.5 something, right?
Oh yeah, our data booklet just says 91.5.
If you could copy and paste the exact thing, so I know that you can use it. Like,
you screenshot it.
Sure thing. Doesn't solve any problem, Kiko. But remember, Kiko, in the difficult integration, you don't erase your previous work. That's a big no-no.
Okay.
That's a big no-no because you're trying to find out what you're supposed to do. You cannot be certain whether something is correct or not. Even if something is a dead end or not, you can only be certain that you have tried certain things. If you erase it, you have no reference to go back to. That's why I keep asking, what did you do? What did you do, so to speak?
Okay.
But of course, if this works, then it works good for you. But if it doesn't, keep it there. Oh, yeah, they present it very nicely. I mean, this means 1U is that. So remember, let me just write out for you. The panel will be delta M C square, right? The C square should be there. This delta M will be 0.5408, right? Times 91.5 MEV over C square, right? Times C square from top. This needs to happen. Why? Do you understand what's going on? Hey, Tristan. Oh,
Oh, okay. Sorry. Yeah, okay, I understand.
This needs to happen one more time. You need to do it this way. This needs to make some sense, right?
Yeah.
Yes. So if you do that, then you just check the answer here. So Tristan, I've seen your work. You're missing something. Okay, just a little bit. So
Which thing?
I'm just pasting. Okay, so this nitrate one, this will be liberated by heating with heat OH minus. There's a OH minus there, and then aluminium.
Oh, minus I
So
couldn't
three
see.
things. Yeah, correct. Three things: aluminium, OH minus, and heat. Three things.
Okay.
So that's how we
Okay, I can
remember it, though, right? Okay, because that's why I can spot it very quickly. Okay, you're missing something. Okay. Other than that, looks good so far.
Okay.
Okay, so I'm going to give you the next one. Ananya, you're saying?
I got it.
Wonderful. Right.
Wait, but the question asks for binding energy for nucleon.
Oh, sorry. Divide that with 59. No? Sorry, I forgot about that. You're right. That's just the last part. Just wait.
Okay.
Oh, sorry, Tristan. I almost gave you the hardest one. Okay, Tristan, I'll give you an option, yeah?
Yeah.
The next one, page 8, is the hardest one, but we cannot make do without. There's quite a lot. The reason is simple. And then there is one more, which is shorter by comparison. Wait. So I put it in page 8 and 9. Considering your stamina, if you're quite okay, it doesn't matter in which order. But if you can do this too. So look at page 8. Yeah, so page 8 is just 4. Don't memorize the rest. Right. You understand? Just 4. Okay. For page 9, I've already taken out a lot which is not in the syllabus. So just the remaining part. Okay.
Sure.
So you choose which one first. Which one do you choose?
I think I'll probably do A first.
Sure thing. So again, maximum 10 minutes. So at 6:30. Oh, when you buy, So to me, Keiko, I'm being greedy. I was thinking, is there an easier way to do this? But the fact is that this is done. This settles it. If it settles it, then it's done. In exam, we don't think about, is there a better way of doing it if we are already successful? That makes some sense.
But it's not done yet, though.
It's not. Oh, goodness me. Wait, what? Okay. Oh, it gets worse. Wait. Let me make it bigger. Let me just end. Oh, you no need. Oh yeah. The by parts of that one will not work, but you're supposed to keep it in mind. Never erase. Yes, right. So is there a better way? So my suspicion was this by part cannot do. My suspicion because it's second. Wait. Again, no. I'm sorry. I cannot say that. Okay, I'm sorry. Okay. So again, I remind you a little bit. So what's the differentiation of tangent square, right? And the differentiation of cotangent square, right? Just to remind you a little bit on that first. Right. We need this. That might help us. Okay. If you don't remember, please refer. Ananya, no new questions right now.
Is it that thing?
Wait, sorry.
Yes. Let me just confirm no new questions right now. How they go? Keiko, you see?
Is it this?
No, that looks like the integration of tangent x, kind of. The differentiation is easier. Hey, I'm so sorry. What am I talking about? The differential of tangent x and cotangent x. So see, I remember also. Yeah. Oh. Okay, first of all, Ananya, so this beta minus is almost certainly the page 129, the reverse of the one you did just now. One, two,
Okay.
okay, almost certainly. We just have to make sure. Just check lah. Just check whether it is truly from neutron to proton, right? Check first lah. If that's the case, then easy lah, right? But make sure you check first. Okay, Keiko, if I'm not mistaken, this belongs to this guy, and this guy will be minus cosecant square. I'm not sure. Would you please check for me?
Oh yeah, that's why I was so confused. I thought you quit.
Yeah. So there are two things. There are two things.
Yeah.
So,
Sorry.
correct. Yeah. Okay. Because I thought I remember wrongly. Right?
It's
So
correct.
secant square, cosecant. Okay. Now. Fortunately, wait. It's very helpful. Meeting for a while, meeting for a while. It's something else. Right. So, Ananya, how is it? Can you confirm that there's a neutron to proton?
Yeah, it is.
I'm checking also. This combined is 92. Oh,
Isn't it the equation I wrote, like the answer?
wait. Oh. I'm sorry. Wait, what? Oh, this is a fission. So that's a fission, right? Okay, right. Yeah. Right. Oh, yes. Right. Yeah, definitely. So this is proton go up, neutron go down, right? Oh. No, you already assumed that is that. Never mind, which is fine, right? So, according to the 129, so, okay, again, time for your slide to shine, right? Actually, it's 130, isn't it? Actually, it's 1. So it's just a total reverse of what happened just now, and what they mean by the exchange particle, whatever that is, the exchange particle is this guy. That means it's not the quarks that we study, it's not the leptons that we study, and it's also, these are the leptons inside the quark. Besides the baryons and the leptons, will be this guy, the exchange particle. Now you're supposed to memorize, or rather in the table, they'll tell you that W minus belongs to the weak one, so weak forces, right? So even if you don't understand this is not a difficult question to answer because you kind of know the Feynman diagram. Right? So weak law, that you don't know what's W minus W plus Z. I don't understand them up to this point. I just believe that they exist. Right? I can kind of explain them, but You don't need it for just for the sake of answering. You don't. Okay.
The question
Yeah.
continues.
I cannot. Oh, there's a minute. So, Tristan, do you think you can just try to write?
Oh, I'm writing already.
Okay, so seems okay for me. So I'm
Only
just looking for
for
the yes.
only for
You're saying, Tristan?
calcium, like calcium is hard to remember the first one.
Fair enough. If you can just don't get mixed, you're already good lah.
Mm.
You're already good. That's fine. Okay, soalannya isotope of barium.
What do I find it based on the graph?
Oh, this is a continuation. Okay, I understand. Right. Okay.
Yeah, there's two more parts actually. The whole question is kind of difficult.
Right. So the isotope of barium that we are talking about must be the 138 lah, right? Must be the 138 barium, right? From the previous thing lah. Right. So I'm just noting that just so that I'm not confused. Half-life of the this guy. So I'll keep it as simple as possible. Yeah? This is what they like to do. They like to have something which is decaying, producing something else, which is also going to decay. What am I trying to say? If the cesium is producing something which does not decay, the barium graph will simply increase as the CS decreases, because the barium is being produced as the CS decreases or decay. Making any sense? Does that make any sense?
I know.
But the barium is increasing and decreasing because the barium is formed, right? So increasing. And at the same time, it starts to decay. When it is formed, it decays. So it will drop. Okay, so if I'm going to cheat for a while, I'm going to take a point where the CS seems to be 0. The CS will never be 0, okay? But if I take this point and I pretend that it is 0, because it's very close, then at this point onward, there is no more CS becoming barium. No more. At this part, this is a proper cheating, I would say. This is where you don't care about the cesium. You don't care about the barium increasing. There's only barium decreasing. It's a pure decreasing barium, which is to say, this is where you can more easily calculate your half-life. Am I making any sense right now? Okay, then please try. People, no new questions so far yet.
Can I ask a chem question?
Of course, you can ask anything. But why would you want a chem question?
I still have chem on Tuesday.
Oh, I what? Oh, what?
Yeah.
I'm very confused.
Last week I took chem and bio paper 3. And then next week I'll be taking chem and bio paper 1 and 2.
Oh, math. Also, nothing is done last week. Nothing is done.
Yeah, except for lit, but I didn't take my lit.
Of course. Okay, sure. Just ask him. Just looking at the integration. No, I don't like. Maybe I'll do by parts. Maybe. Yeah. This time I do okay in right.
I'm going to send you now. Do I do the next one now?
Let me explain a little bit. So I'm just checking. Yeah, looks good. The next one, let me give you a few pointers.
Right. Okay.
Um, a ring. Maybe I've said this to you, or maybe I haven't, but I'm going to repeat that.
Okay.
A negative will always have a positive with it. There is,
Oh.
sorry, in O level syllabus, there is almost no situation where you just have a negative ion or you just have a positive ion. So
Oh.
whenever you have a negative ion, there is always some other positive ion with it. Whenever you have a positive ion, you always have some other negative ion, even though it's not mentioned.
Oh,
That's the
okay.
assumption. Yeah. So for example, when you say this is a solubility table, solubility table means only one thing, whether they are separate in water or whether they are not separate in water. So take example, the famous sodium chloride, your table salt, is soluble. You see before your eyes that the salt will disappear, the water becomes salty, so they are there. But my point is this, they are aqueous, right, soluble, so that means the Na plus decides to fly around rather freely from the Cl minus. That is what soluble means. If you take chloride with somebody else, for example, silver, right? Ag and Cl, Ag plus and Cl minus, will decide to stick together inside water. Therefore, forming a precipitate. That means it's insoluble, so they do not want to separate. Insoluble means that.
Oh, okay.
This table only means this. So if there is a pairing of bromide and lithium, will they separate or will they not separate? Bromide, lithium, separate. Bromide with Ag plus, not separate. That's what it means, and it will be very helpful. I mean, next time. So that's the first pointer. The second pointer is very simple. Look at sodium, lithium, and potassium. I'm sorry. Look at the first four. 1, 2, 3, 4. Right.
Yep.
I cancel a lot. What remains? They are always soluble. Right. Isn't that your conclusion? Potassium plus, no matter who he meets, they will be apart.
Oh.
Right?
Yeah.
Sodium plus, no matter who he meets, they will be apart. Lithium plus, the exception I cancel. We don't care, right? The cancel one, don't care. Man. Oh, lithium plus, no matter who we meet, he is apart. A plus, no matter who he meets, they will be apart. It's so simple to memorize now. No matter who, they will be apart. Simple, right?
Yeah.
Nitrate, no matter who, he will be apart. Cl minus, Br minus, and I minus. Look, no matter who, they will be apart, except for these two guys, which is, by the way, a repeat offender one. They always like to combine one. They are very unlikely to be solved. What I'm trying to say is, don't memorize one by one lah. We die lah. We memorize the exceptions, for example, if you understand what I'm saying.
Yep.
Okay, now let me point out one more time. For hydroxide and carbonate, it's mostly they are not going to be apart. See? They're just not going to be apart, except for who? Except for the first four, which you already know.
Yep.
You understand?
Yep.
You must find your shortcuts in memorizing. 15 minutes, but that's all. At most.
All right.
Yeah, back. Oh, sorry. Okay. Ananya first. All right, Ananya. So tell me,
Draw table.
you can draw on table, or I suggest you summarize it your own way.
Okay.
That means you think about how you want to memorize this. This is your last thing anyway. So spend the time on it. Ananya, tell me what's the page 11 is okay, right, Ananya? I mean, that's it, right? You should be taking what? Oh, you're reading the graph more precisely than me. I thought the answer is 100, but it's less than 100. I'm sorry. So I'm totally fine.
Yeah.
Okay. Good. Why is it 335? Oh, yeah, 3. Yeah. Okay. So, yeah, correct. So, okay. So, yeah, it's my mistake. Okay, so what's with page 12, Ananya?
I don't know how to. What does it mean? I'm so confused.
Oh, goodness me. I mean, they like to ask this, but I'm going to ignore that for a while. I'm going to go to page 13. So it'll take some time.
Okay.
The first thing first, Ananya, for page 13, you must realize you must write down the reaction first. It will be much easier for you. Can you do that? Because they actually tell you in English, write down. Understand? For you, Keiko. Okay, this one I can understand, Keiko. So what's your question, Keiko? Nice. Okay.
I think it's this part, and then like this, cause I can't really like. I don't know. I cannot add pH, right?
Okay, so let me try to let me try to make sense let me try to make sure that we are thinking about the same thing. Right? So I'm looking at this. So obviously this is your H2PO4 minus, and this one is your HPO4, right? And 2 minus. So they will be doing this guy, no? Similar. They'll be doing that guy. That's it.
Then how do I use this value? Because it's total concentration.
Right. So here, right? Oh, so wait. So I believe we just have to deal with the guy in the middle. I believe lah. At least that's why I believe. Okay. So obviously we don't have concentration. We only have mole, right? We only have mole. So mole will be X will become X and X, right? You know this, huh? You know this 1, 1, 1, 1. Right. So I'm so sorry. Yeah. So X will change. Like this one will change. So the one that is left, right? That is left. Let's say the original is, I don't know. The original is Y, right? I don't know. So Y minus X. So this is X. This is X, right? Then the volume will be over V. It will be over V. So currently you have the concentration.
Oh yeah, yes.
So I'm not sure how this will help us, but at least I will start from here. Use the KA, use this and that. And then also 7.4 will help me with this. 7.4 will help me reduce one of the unknown. Plus the 0.3 also. So I'm using everything to try to resolve that. So the 0.3 will be this plus this, right? That should be helpful in reducing one of the unknowns. Am I making any sense?
I think so. Okay, wait, hang on.
Right. But of course, in this MCQ, if I am particularly not, I will just actually test one by one. Actually, I'm thinking like a long answer question. But if I see that I'm just gonna try one of this in the formula, but If that doesn't work, then I'll do it the appropriate way. Right? So am I helping you a little bit?
I think so. I didn't even know how to approach this at first.
Right. But I will argue that this is not very, it's a bit basic once you settle the equation. There's a confusion. So Ananya, are you stuck with the reaction? Are you stuck with the reaction? Are you there? Are you okay?
Hello?
Yes. You're muted. Are you stuck with the reaction?
Yeah. I don't know if it's
Yeah.
alpha plus nitrogen, 2 oxygen plus proton, or nitrogen 2 oxygen proton alpha.
So I'll just reading the question. Right?
Okay.
So if you say that bombardment of nitrogen by alpha, I think it's safe to say it's nitrogen at the start and alpha at the start. Quite safe. Then he said that the nitrogen is transformed to oxygen plus proton, right? This will be 4-2, right? This will be 1-1, right? Oxygen will be, I think, 8, right? 8, and this is 7, right?
Yeah. So, yeah.
Wait, because the number doesn't match. Oh, the number do match. I'm sorry, number do match. So this one is a question mark. This one is a question mark, right? Because we don't know what. Right? So I'm writing this to help me get a sense that okay, this is what's happening. That's for me. If you understand the English and you don't need this, then it's okay. You do you.
Okay.
Wait
I
for
think it
the
will help. Sorry.
Because you may feel like it's different. From my side though, that's what I feel. And then now I can start to think a little. So everything here can be put into this. And so I'm just gonna go write it down. So this is your 4.00 something. The nitrogen will be your 14.00 something. Now here 16.99 something, and your is 1 point. Okay, so what he's saying is this, right? This mass plus this mass definitely won't match one. Okay. The question says that the alpha particle requires a certain energy, which means I am guessing that their total mass will be smaller here than the right hand side. Meaning you have to compensate the smaller mass with the additional energy. Am I making any sense right now?
It's the left side. Should have a smaller mass.
Small mass, that means he requires energy to make up for, hey, I'm transforming to something bigger, right? More mass. From where? Yeah. Must be from some energy, right? Must be. That's the logic. Okay.
Yeah.
Okay, then you guys try that. Release up. Okay, there's the key one. It's a No, you mean you found the X? If nothing wrong, you found the X, right? Oh, then everything is easy, lah. Hey, wait, no, you don't have the Y, but you can find the Y. Oh, then once you find the Y and the X, you're done, right? I know.
Okay.
Maybe. I'm not sure whether it's a shorter way or not, but the way they give it is, they are giving data in a very unwilling way. They are trying to just, complicate the whole thing. So I feel like. So maybe there is no shorter way. I don't know, maybe. Kristen, are you okay?
And wait for that table, right? Is it alright if I like mark out those that are insoluble instead of the soluble ones?
Correct. I
Is that
believe
more that
you
better?
just memorize what is the simplest or the shortest. That means for chloride and bromide and iodide, right? For example, right? You memorize that with Ag plus and Pb2 plus, they are all insoluble.
Yeah, only that, right? Then the others, okay.
Then you assume that the rest are soluble because that's how you memorize.
Oh,
correct.
Okay.
That's how you summarize the table for yourself. Make sense?
Okay.
You should do that. Yeah, you should do it.
All right.
Amanda, let me confirm. The left hand side is thinner than the right hand side. Yeah. This is good.
Yeah.
Sorry. Yeah. So lah, done lah. 4 marks. Nice. So you decide lah. Writing the reaction is a burden or is useful.
So in this case, like the proton number of the nitrogen and oxygen doesn't really matter.
Because they give you the total, the rest max already. So I noticed that, so it doesn't matter. But for me, writing the reaction feels clarifying. I'm not sure whether that makes sense to you. So I will do that. I will try my best to do that, even though it doesn't seem to be needed.
No, I don't mind doing it, but like I won't have a periodic table, and I don't take chem, so I'm like, I wouldn't know.
Then I guess that explains why they give you the English, right? They give you the English. So the worst thing you can do, if you feel that this is a helpful thing, then you don't care about the proton and nuclear number lah. You just write down this way. Right? That might already help, because remember, we are writing this to help us, not because they ask us to. So don't see it as a burden. If you don't find it to be helpful, then your option is to understand the English, so to speak. Is it Keiko? Is that working well?
Okay, so if I do the 10 to the power of 7.4, right, I'll get like a huge number, but then, okay, let me just write it down.
How come the 10 to the power of 7.4 doesn't seem to make sense? Wait a minute. Hey, it's minus. It's minus, leh. It's minus. It's minus. Why is it a 10 to the power of 7.4? pH is minus log base 10 of the concentration of the.
Oh,
by the way, this is not X lah. It's X over V lah. I feel lah. That's X over V. The concentration man. So just to be clear, that's X over V first lah. Just to be clear. Yeah. So yeah, that's more now.
Okay.
Yes, Ananya.
Can you read this page 12 in the Jambra?
Oh, this page 12. Sorry. Kristen, okay so far?
Yeah. For hydroxide, right? Like I don't need to write about magnesium, right?
Wait, I don't see.
You crossed it out, right? I think.
I did. Yes, I did. Yes, no need.
Oh, okay.
So Ananya goes like this. When we're talking about this binding energy per nucleon, the situation is this. Proton stays proton, neutron stays neutron. There is no beta plus decay, there is no beta minus decay. When the proton actually changes to neutron, but I'm so sorry. So at this section of the discussion, right? Even the chapter here never discussed the quantum physics, right? Not yet, not as in not yet the the quark law, the Feynman diagram, all this. Not making any sense.
Yeah.
So if you see this chapter, your assumption is fusion and fission. Your assumption is proton stays proton, neutron stays neutron. Okay, that's a reasonable assumption. Then we can kind of eliminate the complication. I'm not going to complicate things by saying proton changes to neutron, neutron changes from proton. Let's just assume that it doesn't happen in fission and fusion. Would that be okay? Yeah. If you have an objection, you come here. Right? Now, once that is A, then what he's saying is this: binding energy is basically the loss of mass, right? If this doesn't make sense, you tell me. If you have a higher binding energy, you have lost more mass when you go from individual proton and neutron into your combined state. Again, am I making any sense?
Yeah.
Higher binding energy, higher loss of. Now, look at Happy. Per nucleon, each nucleon, very simple, each proton, each neutron in Fe has lost a lot of mass. Binding energy is the loss of mass. Every nucleon in Fe has lost a lot of mass, much more than the rest. This is the thing. Making any sense?
Yeah.
So he cannot lose anymore because he has nowhere to change to. If I force Fe to undergo some sort of fission and fusion, he will change to something else, right? But that something else is gonna be something which have lost less mass, which is to say he has to add mass already. The peak, the Fe. If he has to add mass, then you have to give him energy. Giving him energy is not generally the goal of fission and fusion. The goal of fission and fusion in general is to produce energy, which means I'm aiming for greater loss of mass. Am I making any sense?
Okay.
So now, to keep it simple, fusion. Here, fission. Here's the last logic. So on the right hand side of the graph, if I go from uranium to, I'm so sorry. Correct. Yeah, correct. If I go from uranium to lead, I will be losing more mass. Correct?
Yeah.
This is called fission because fission will allow me to go from something bigger to something smaller. That's what fission means, correct? Breaking up something big.
Yeah.
If I do that for the right-hand side of the graph, then I will be losing more mass, therefore hopefully gaining energy. I fission. If I fusion, not a good idea, need energy. Okay? The left-hand side is different. I want to go from something like here into something here, for example. Why? Because I will be losing mass. Going from small to big is called fusion. Fusion simply means combining small things to something. If I go fission, breaking it down instead, I will be needing energy. Also, not a good idea. Fusion on the left, fission on the right. So I can release energy, get energy from fusion if I choose the proper place. I can get energy from fission if I choose the proper place. So you understand what I'm saying?
Mhm.
Those are not the formal words. Those are not the formal words. Get the meaning.
Mhm.
Okay. For the formal words, you can look at the answer kilo and see whether that makes sense or not. Kiko, you're stuck here. Am I correct?
Huh?
So Annie, yes, Annie, go ahead.
So basically, if they give me a similar graph with different elements, fusion would be like from small to the largest one, which
Fusion is
Fe in
always
this
from
case.
small to largest. Yeah,
Okay.
fusion is always from small to largest. Fission is always from large to smaller, right? Always like.
Yeah, okay, fine.
But you have to choose the appropriate things to fission or fusion, so to speak.
Okay. Yeah, okay, thank you.
When do we see each other? I mean, this is an exam later. When we see each other, we see each other again on.
This week?
Oh, this week is done already. No, we are not seeing each other again this week, isn't it?
Like the coming week.
So this week no more. I mean, you'll be
Yeah.
having an exam. And, okay, understood. Okay. Okay, Kristen, I'm checking.
Already like that, it's okay, right?
No, the summary is great, but I noticed some mistakes. But I mean, doing very well. So
Oh, okay.
I mean, we'll be ending soon, right? But I'll just correct you, and then next week, if your teacher haven't caught up, teacher cannot,
Okay.
then we'll repeat this very quickly, and then we go to the question immediately. That's what we're doing.
All right.
And this one is the same, so that's great.
Oh, so it is. Oh, okay.
Yes, okay. But then I will suggest just memorize the soluble one.
Oh.
Easier, ma?
Oh, yeah, true.
Like the first four, right? Whatever,
Yeah.
first four done already. Okay.
Oh, yeah, that's even easier.
And then
Yeah, okay.
mention nitrate, all soluble, right? All soluble. The first four, you must remember the first four. Like the first four is NH plus, right? You know, lithium plus, Na plus, K plus, all solubles, right? So this one, and then your hydroxide. Actually, I will argue that your hydroxide is just the same as carbonate, right? Hydroxide is the same as carbonate, except for barium. I will argue that, right? The rest is fine.
Yeah.
You understand?
Oh, okay. I think for carbonate, it's easier to remember the soluble one.
Yeah, soluble is first one, the rest is insoluble. Hydroxide, same thing, except barium plus.
Okay.
I think you got it. You roughly got it. Not too tiring.
It is okay.
Okay, then I'll see you next week and we'll make use of it. Okay.
All right.
Okay, good job, Stan.
Thank you. Bye-bye.
Ananya, any final questions?
No, I think so.
I'll still answer questions through WhatsApp lah. It's exam week, right? Okay.
Yeah. Okay.
I'll see you after the exam. Okay.
Okay. Are
Bye-bye.
we sticking to Thursday?
Yes, Ananya.
Or are we going back to Wednesday?
Oh yeah. This Thursday I don't. Wait, what? I'm sorry. Are we doing what to what? Sorry.
No, because initially I was doing Wednesdays with you. Then last 2 weeks I think we did Thursday. So are we sticking to Thursday or Wednesday?
You're talking about the normal schedule, right?
Yeah.
For exam. Okay. So I was under the assumption that the normal schedule is Sunday, which is right now. Actually, there must be a confusion somewhere. I put it that way,
Isn't 2 a week? I thought it's twice a week.
Oh, okay. Again, misunderstanding. I don't mind twice a week. The Thursday slot is fine. But I was assuming that you only need once a week. after you caught up.
Okay.
I was assuming that, right? Oh, you have basically caught up. No, let's see what happened in exam lah. If the exam is not so good yet, then maybe we need twice a week, which is your Thursday block. That's totally fine. Okay. So to see whether we need once or twice, we should discuss it next Sunday lah. Okay. What do you think? We need once or twice? Okay, makes sense.
I think once is okay. Yeah, I'll let you know next Sunday.
Okay, let's confirm it next Sunday, right? For this Thursday, just exam week, just rest for a while, huh? Rest for a while.
Okay. Okay.
I'll see you on next Sunday. Okay.
Yeah.
Bye bye. Right, okay, cool. Sorry it takes so long, huh? I see that you have been stuck for quite some time. Am I correct?
For which one? The Chem one?
Yeah, the Chem one.
I mean, when I do a 10 to the power of negative 7.4, right, it's like 3.9 times 10 to the power of negative something.
-6 lah, right? -8, -7, -7, and -8, sorry, -8. It's a small number.
Yeah, it's 8.
Yeah, and then at that point you feel uncertain lah.
Yeah.
Which is not any of the answers. Okay, hang around it. Now it's empty. Let me check a little bit. Yeah. Okay, first thing first, right? So this means the y is much bigger than x, right? So let's talk about first thing first, right? Oh, there's two originals. See, I forgot. There are two originals, right? Yeah, y and z, right? Y and z. Z plus x. I kind of missed that already, right? So there was y, there was z. Yep. Oh, wait a second. I was assuming that H2. Oh, that was a bad assumption. I apologize. Okay, I did a mistake. So look at the reaction. The reaction is me assuming that there is more of this, therefore it will shift to the right-hand side. More of this than that originally. Therefore, I have to make a shift, and therefore I'll create more H plus, which is obviously what the equation is. See, the pH is less than 7, indicating that some H plus is created, right? Now, let me see whether that assumption makes sense or not. So, cannot be. So, oh wait, cannot be, right? So, whatever that buffer is, the pH is not 6.7, the pH is 7.4. So that means it probably is the other way around. There's more of this guy than this guy. So more than the balance allowed, more than what the balance allows. So there'll be a shift to the left instead. Okay, the shift to the left will cause it to be 7.4. So the assumption should be a shift to the left. Now, more doesn't mean 1 by 1. More than what is allowed by the balance, if that makes some sense. The balance must still be this. I'm off balance such that I have to shift to the left instead of shifting to the right. So what will happen is shifting a little bit. I'm overcomplicating. So you have your original, which is this is your, let's pretend that this is your Z, this is your Y, right? So I will have a change of minus X plus X. It will be minus X. I don't think that matters a lot. And then I'm left with really does not matter. Right? So the reason why I still write down this guy on the right and this guy on the left, because I still want to oh dear, can I that is a PKA. Oh, I think carefully. Hang on here. I cannot use the PKA. Because I'm not sure what's going on here. Okay, totally none of this makes sense. Right, so I'm holding this one. Confirm you don't have any other questions so far.
No lah. It's just this. I mean, it's only 1 mark, so it's because I'm secure.
Right, for 5 more minutes. If not, then I'm just going to change this. Let me confirm, Keiko, that we can integrate second x quite easily, correct?
Okay, integrate second x square.
Quite easily. No, second x only.
Second x, yeah, MF26.
I'm sorry, you're saying? Sorry.
We can use the formula in MF26.
Oh, sorry. Yeah, okay. Understand. Then I think by parts should work. No? So I just confirmed that just now. So what I did is this one, which should be easy. I get page 9.
Okay.
So I assign this as dv dt lah, because I know I can integrate this to tangent x. Make sense? This is my dv dt, this is my d lah.
Okay.
Right? So I was trying out that. I'm not saying that I know. Then this is the u, so I have to differentiate, right? Differentiation of sine minus 1, right? Minus x will be minus sine minus 2x times cosine x. Making any sense?
Yes.
So the question is, can I integrate v du, right? Can I? I think can, right? So this times this end up being minus 1 over sine x minus integration secant x dx, which I cannot. I think the first by part should settle it out.
Okay.
Does this make any sense?
Yeah, it does.
Okay, so what am I doing? I'm just using whatever combination I can think of, and hopefully that works. That is really what I'm trying to do. I was trying to remember this. It may come in handy. I was trying to remember the identities. It may come handy, right? But I didn't know what works until obviously I do it. I didn't know it.
Okay.
That might be the thing that bothers you. That might be, no? Am I correct or not?
Probably because like it's still timed.
Oh yeah, it takes time. Furthermore, what is the most annoying thing is that the integration of secant square x, right? We will instinctively think that it is easier than secant cube, right? I don't think so. I think that would be, is it possible? Is it possible? I don't know. I don't know whether it will be easier or not. I think maybe integration of tangent x is, no. Can you integrate tangent x? Can you integrate tangent x? Okay, I guess you can by parts, right?
Maybe.
Yeah, but my point is, if I try to by part secant square x, it is not necessarily easier than secant cube x. I can do it. I think I just have to by parts integration of tangent x. Wait, tangent. Wait.
Actually, no. Sorry, there's a
No, I
formula
cannot.
for that in MF36 also. For
The
tangent
integration of for tangent x.
Yeah.
Oh, I can tell myself I have to be integrating x tangent x, which I don't think I can do. I can differentiate x tangent x. I cannot integrate x tangent x. My point is, integrating doesn't follow any common sense, especially when you deal with power. Power 2 doesn't mean it'll be the same as power 3. Power 3 doesn't mean the same approach with power 4 works. That makes it even worse. If that's what you're thinking, welcome to integration of trigonometry. Makes things worse. All the power 2, power 3, power 4 doesn't have a necessarily well-defined profession.
Okay.
If that's your difficulty in trigo, no wonder.
Yeah, this is from a Hwa Chong paper. So.
What is your best bet? Just do everything. Just do power 2, power 3, power 4 from the start. Okay, and yet they can just mess you up by putting a power 3 and another trigo. They can just mess you up that way, even though their attention might be to actually help you. Maybe.
Okay.
In short, integration of trigo is like that one. No? In that sense, who cares? Just leave it behind and do it with a free mind.
Okay.
I mean, again, human words, I was lucky that my suggestion for the by part, the first one, seems to work the first time. I suggest one thing just now, it doesn't work. I suggest the second one, it works. I was lucky by human terms. It could have been 3 or 4 efforts. And maybe after 4 efforts, I just give up. Or maybe time's up, more likely. Okay, that's just the nature of creating many power trigonometry. I'm sorry, that's the limit of my skill. I can only try lah, I suppose. Okay. Now, let me put it another way. If this is your only problem, you have no problem. You can score A very easily if this is your only problem. Really. If this is not your only problem, I suggest that we focus on other problems. If this is what you mean by manipulation, this is not manipulation problem. This is creativity problem. This is the ability to think when there is no obvious solution. That's not a manipulation problem per se. Is this what you mean by manipulation problem?
I mean, okay, for the exam itself, right? What was the function again? It was something like this, I think. But if I try to, equate this to y and then express x in terms of y, I will end up like getting x cubed. Something.
This is supposed to be This is supposed to be
I need to
Maclaurin,
find
is it?
x first.
Maclaurin, am I correct?
No, F inverse and F inverse.
Oh, goodness me. Oh,
Yeah, so okay, maybe for the simpler ones, the manipulation is really not that bad. But for something like this, I have no idea how to handle it.
fair enough. If that is what you mean by manipulation problem, then I guess you do. I cannot say that you have some problem lah. I think everybody will have some problem lah.
I mean, that's true.
If this is the problem, well, it is a problem, fair. But
Yeah, then for the vectors, right? I realized because they were asking for the perpendicular distance between two skew lines, and then yesterday I was just randomly looking through the H2 math syllabus outline, and then I saw that they excluded that from the syllabus.
Yes.
So yeah,
That's not easy to
what
find.
I was doing.
Yeah, that's really not easy to find. I mean, no, I'm not sorry. No, it's not fair to say that it is. It's fair to say that it is harder. It is fair to say. So if that is your problem, then you just ignore it.
Okay.
Currently, your problems, the problems that you describe are very honest problems. Well, I mean, obviously it is a problem. It's not because of a natural skill gap or something that is easily fixed. I definitely for tomorrow or this week's exam, you are not to worry about it. Definitely. I'm very sure about that. Whatever happens, happens.
I
We
think I
need to
just
worry
really
about.
I
Yes.
cannot be careless. I just really cannot be careless. That's it.
But there's a lot of pressure to say to yourself, I mean, in exam, you are allowed some carelessness as long as you can check and find it.
I guess.
The moment you say that you cannot be careless, if you really mean it, that means you're not going to be very successful. Because nobody can be fully not careless. That's asking a lot for a human to do in a math exam Zamora, and it is unnecessary pressure.
Okay.
Why are you saying that to yourself?
I mean, compared to the past when I was doing like A math and E math, I wasn't like that careless.
Wait, seriously, the level of difficulty is
I mean,
it's tremendous lah. There's a tremendous difference. To be fair, we haven't discussed any ways to catch the careless mistake or minimize the careless mistake. We were just doing stuff. And here we are finally talking about careless mistake. Do you notice that? We are not really talking about conceptual problems already. You're not talking about there's a reading problem. So you have progressed until the level where you worry about your careless mistake, dropping your, result. To me, that's a good news. I'm not just trying to reduce your pressure, okay? I'm not just trying to do that. Really, to me, you're already at that level where you just have to worry about your careless mistake more. And no wonder we haven't been talking about that until now, because we have been trying to settle all the conceptual black, right? Which means you are you are not having a lot of lag. Okay. And frankly speaking, for this exam, that's enough. Not a lot of school is crazy enough to ask their students to do almost prelim syllabus by July, early July somewhere. So if you're already covering the syllabus in the sense of the concept, that means you have done very well up to this point. Okay, one of the ways where you can, sabo yourself tomorrow is to tell yourself you cannot make any careless mistake. No, you should simply stick to the goal. Okay? You should first try your best to not forget or commit any conceptual error. And try your best to not commit any reading error. Remember the goal. The goal was never to make no careless mistake.
Okay.
It's not that you can make careless. I'm not saying that, but settle what you have learned first, right? Okay, you're gonna read. You're gonna remember all the concepts that you have done. The execution can be a bit wonky at certain questions, only at certain questions, and you are allowed to do that. You're allowed to do that even in A-level. Because for results with buffer, you're just aiming for around 88%, 55 to 88. That's a lot of buffer for weird stuff like sickness, right? You're not aiming for 100%. So if you're, with buffer is 88%, that means you have leeway for careless mistake, even in A-level. And you're not the type who wastes that anyway. So saying things like, you cannot make any careless mistake is unnecessarily pressurizing.
Okay.
You understand me?
Yes.
Okay. The most important thing is you haven't trained for it. Because you couldn't train for it. You couldn't. Not until recently lah. Yes, Arya, I can see you. Just a minute. You understand me, Keiko?
Yes.
So do your stuff lah. Do your stuff. Okay. I still owe you the chemistry. So I guess that one cannot help you. Okay.
Okay.
All the best. I'll see you if I see you on Thursday, I'll see you. If you feel that you want a break, then you just take a break. Okay?
Okay.
All right. All the best. Bye-bye, Kiko.
Thank you. Bye-bye.
Bye. Yes, Mr. Arya, I can see you.
Hello.
Yes. Hey, stop using rock. Yeah, I can't really hear you much. Okay, but that's Kirana. So, okay, Kirana's video, I can see you, Kirana. Okay, Hey, Kirana and Arya, same thing, yeah. Just update me first, right? Update me during using Jamboard, okay?
Okay.
Arya, if you're having technical problems, please tell me, okay?
Oh no, it's because my family is talking a lot.
Oh, sure, okay. But your connection sounds good today.
Yeah, it is.
Wonderful. Just update me first. I'm predicting that today will be a bit relaxing for you because you've been doing a lot. But if there is any important update, I want to know. Right? Hey, Kirana, you're updating me. Okay, Kirana, which Jamboard are you? Oh, wait. Okay, I don't think we're in the same Jamboard. I was looking at the Jamboard from the Jamboard titled Kirana. That was from last week.
Oh, okay.
Yeah, I think that one. Maybe, I think so. Yeah, I think so. Maybe you just update on page 1. So I've created a new page 1 for you. A new page 1. If you go to No, no. You go to the page slides. Press the rectangle. Press the rectangle. Okay, go to page 1. I have created for you a new page. There you go. Okay. Maybe you do your updates here. Okay.
Okay.
And let me get something first here. Kirana, if you could landscape, please. Nice. Kirana, what's chapter 9? They might be again.
The Pythagoras.
Oh,
Like-
that means you are finishing the similarity, right?
Yeah.
Wait, really? The map question, remember we're doing map question last time, right? The map
Mhm.
question is done. Your teacher finished with that. Really?
Yeah.
Did
Like
your
that.
teacher rush through the
Chapter
map
9
question?
is holiday assignment, but I haven't finished yet because I don't know how to do.
But I know. But did your teacher rush through the map questions?
Like for what chapter? Chapter 9.
Map was chapter 8, man, 8.3. Remember, we were doing it last week, map questions.
I don't know because I wasn't in class for the whole week.
Oh, you were sick. Okay, of course.
But like I already do all the
So-
assignments for the
Okay, fine. So you go into school already, right? So your school is still talking about Pythagoras.
Yeah, I think so.
Harder questions or the basic questions?
I think the basic ones. Actually, like, because chapter 9 is supposed to be for self-revision, so probably they're only checking the answers.
Wait, how come you don't know?
Because I
I
wasn't
thought
in
you're. Wait, when do you wait? Have you start to go to school? No, right?
No, I haven't.
So Thursday was holiday. Friday,
Friday I didn't go.
but Friday have school lah.
Yeah.
Oh wow, really? Okay, all right. So today we do the Pythagoras lah.
Yeah.
Okay, I guess I will wait for your update more tomorrow and what Tuesday lah, because tomorrow you'll be going to school.
Tomorrow is holiday.
Monday is holiday. Yeah, I
Yeah.
didn't know that. So Tuesday you'll be going to school.
Probably.
And what do you mean by probably?
I haven't tested ART yet. So like I don't know if
Oh.
Yeah.
Anyway, let's talk about Pythagoras. Okay, I'll follow you. Yeah. Okay, Arya, do you have something for me? Do you have a Jamboard for me?
There's no new Jamboard, right? I have to use the old one.
Okay, we'll start from the old one. Okay, man, I'm so slow. Okay, so Arya, maybe a quick update. So what's happening in school?
Nothing. We just went through our holiday homework.
Okay, now your connection is bad.
Huh?
Yeah, just now
No.
I cannot hear you. Your connection is bad.
All we did was just go through holiday homework.
Right. Okay, right. Okay, I actually forgot that you have a holiday homework. You finish it before the trip, isn't it?
Yeah.
Okay, understand. So nothing new, right?
Yeah.
Right. So to keep up with our pace, we will talk about. No, we have already talked about almost everything. Almost everything. Almost everything.
I think we
Yeah,
should
we
start
should.
doing the exam practice again.
I think so. I mean, that's all we need to do. You know, I'm already tempted to teach you more than Sec 1, right?
My WA3 is in like 3 weeks.
Then you should have topics for WA3. What are they?
It is from graphs to
Okay. Wait.
polygons.
Okay, Arya. Okay. You must make a new Jamboard because the old Jamboard is almost done. So make a new one, share it with me, and then please type those topics in. Okay, let's start. Okay, let's start with that. Kirana, you have some. Oh, you have something already. Okay, Kirana, you help me a bit now. I'm asking you to turn off your video for a while. I think because the connection is very bad, so that might help. Okay, please turn off your video. For now, okay. Yeah, okay, right. Hopefully that helps because the connection is very bad. I cannot hear you much. The Jamboard is loading very slowly. If you can hear me well, would you please tell me?
Yeah, it's like your voice is
Okay.
not lagging.
See, your sound is also not very nice. Yeah, so the connection is a bit bad today. Okay, so I'm page 7. Yeah, are you? Yeah, page 7. Yeah.
I'm not sure how to do this question.
Okay, Kirana, I'm writing something on the board. Can you see it?
Yeah.
Okay, if you can see it, please respond a little bit. Okay, so Kirana, you can do the first one. Are you saying that the first one is a little bit confusing?
The drawing makes it confusing.
Okay, then let me give you a hint. Okay, in case they give you confusing questions, you should just focus on one triangle at a time. Pythagoras means 90-degree triangle. So you should redraw a triangle that you suspect will be useful. It may not be, but I mean, you have to start with some triangle. So you suspect that certain triangle help you. You redraw. You make yourself clear.
Like,
Which
wait, what do you
triangle
mean?
would you like to focus right now? The
Also
drawing
find
makes it
triangle.
confusing. Look, the drawing makes it confusing, but you should decide on one triangle to start, right? Okay. You should just decide on which triangle should I start with for finding the pole. I mean, it's PR, so I think the triangle is rather, it's not very mysterious. That means your decision is to decide which triangle first. Just one, right? Just one.
PRQ.
Yeah. Then you draw that first. You redraw that.
Draw.
That's your decision. Yeah. Draw again. Do you have any trouble drawing?
Draw it on the paper, on here. On like the
On
white.
your work or your working place, right? Yeah, Arya, I don't see any new Jamboard yet. Do you have?
I shared
Nice,
it with you.
Kirana. Wait, I cannot see it. So try again. Oh my, today is very, very slow. Ah, yes, I got it. Okay, Kirana, remember what I said? For a Pythagoras triangle, it must be 90 degrees and you must know two other sides. So you must know two sides. Do you know two sides? Not just the drawing, but what you know.
What do you mean?
Okay, Kirana, wait, what's going on here? Whoa. PQR, right? 90 degree, yes or no?
Yeah.
So you should be labeling all this and doing the 90 degree because you know that that's important. Label quickly. Right. And then also what is given? Okay, understand, Arya. We have three sides, Kirana. Which sides do you know? Write it down. Hey, wait, why are we? Why are you very confused, Kirana? So I don't get this. Why are you very confused? This is very basic. Once you have one triangle.
Wait, isn't it you need to label the length of each side?
Let me ask you this. For Pythagoras, do you need to know the sides or not in order to do something?
Yeah.
Then you do that. Then you find what you need. I'm saying this because you're not an amateur in Pythagoras. You're experienced, but you're very confused right now. Wait, I thought it's quite obvious when you have a triangle, something square plus something square to something square. Then it would be good for you to know the sides, Okay. All right. So put in what you find useful, right? Okay, you find that useful, sure thing. Okay, you find that useful. Okay, sure thing. So now you know two sides. You have one side left. Can you use Pythagoras to solve the problem? If our Pythagoras is rusty and you try to jump here immediately, then I suggest that you look at your previous Jamboard Pythagoras yourself. Maybe you're just very rusty. At this point, I'm very confused why you cannot do it. This is like so simple already. You must be rusty, I guess. It's not the question very difficult. It's you rusty. Okay, Arya. Pattern ratio percentage.
Yes.
Can we say that your ratio percentage and polygon are okay right now?
Yes.
Your speed, you never ask. Is it okay?
Yeah.
So what do you think about your pattern? It has been 1 month since we do things.
I'm still okay with my patterns.
I believe so. We just have to try a bit. Now, your
Oh, wait,
graph,
I
I'm
want
not
to
very
ask you
sure.
a question. Can you go to
Yes,
the word?
please. Oh, of course, I'm here.
Yeah, so wait, let me type in the question.
Yeah.
Okay, can you find the nth term of the nth number for this?
Do you want me to do it?
Yeah.
Don't forget that we always start with rainbow, right?
Yeah.
Okay, so, right? We start with this, right? That's what I taught you. The rainbow will have to combine with the n. That is a good start already. This is, however, of course, not the answer.
Yeah.
So n equals to 1. This one, the answer is 6, correct?
Yeah.
So I want 56, man. Well, that's easy. 50 plus 6n, done.
Yeah, but then the next one would,
Mhm.
but then 50 plus 6n will not be equal to 50 in the next.
So very scary, right? The reason is very simple. Because the rainbow is not plus 6, it's minus 6.
Yeah.
So now we change it to minus 6 first, right? 50 minus 6n is not 56, correct? It's I think 44, right? So okay, I'm gonna add more. I'm gonna just change this to 62. Okay. It's 56 again.
Yeah.
So try the n equals to 2, see whether it's correct or not.
Oh, okay. Oh,
Now, this is new, right? So
yeah, yeah.
do you
I get it.
understand? Do you understand?
Yes.
Okay. Isn't the thought process still the same? It's just that I'm dealing with minus, so I just have to get used to it.
Yeah, okay.
Isn't the 62 like a lot more like my guessing, like 62 is like me guessing, right?
Yeah.
Yeah, and so same. Good question, by the way.
I got the answer for part A.
Okay, wonderful. So and then there's this, right? This is now going on, right? So for part 2, I believe. Oh, I lost your Jamboard. Oh, there you go, got it. So we'll be needing this for part B, but Kirana, part B is the same. We still need to focus on one triangle in the end. It's always like that one. Okay, do you understand what I'm saying?
Yeah.
So which triangle are we focusing to right now?
Wait,
Think about the triangle you want to focus on. Okay. Any other question, Arya?
no.
Okay, so let's say your patterns is fine. So I just left the graph. I'm not sure what graph do you mean here. Is it the line graph?
No. No, I'm okay with all the subjects. All the patterns.
Even the graph?
Yeah.
Okay. So, shall we just jump to the paper, but just do this 6 topics? Is that your recommendation?
Yes.
Now you have my papers from the what do you call it, from the Google Drive, right? Is that enough?
I guess.
Okay. What else to do? Let's prepare for your exam. What else to do?
Wait, the question asked to calculate YR, right?
Yes, YR. Yes, correct.
Okay.
YR. So, but the question remains from me to you. What triangle will you use?
It's the is the YR got this one? No letter. The top.
You can make you can create your own letter. By the way, you're allowed to do that. Please create your own letter.
Wait.
Okay, now you cannot double XL, cannot, yeah, cannot. Okay, okay, Z. Now, here's my question. Is YRZ perpendicular? Perpendicular, a right angle.
No.
Then, can you use Pythagoras in YRZ?
Oh.
Cannot, right? Cannot. Doesn't mean that you cannot use that triangle, but you cannot use Pythagoras. Are you willing? Are you willing to use that triangle still?
Mm, I think you can still use YXQ, right? You can just minus.
YXQ.
Like, if
Correct.
you want to
As
find
in-
YR, then you can just find YQ first and you minus 1.1.
Would that make sense?
Yeah,
At least you can use Pythagoras, right? I mean, that's the benefit, lah. Correct or not?
yeah.
Okay, that's what I mean by deciding the triangle. You decide, you think, oh, yeah, you don't like it, you switch triangle, lah.
Okay.
It works, right? It works. Go ahead. Okay, so Arya, tell me, are you looking at the question right now and you're just doing on paper? Is that what you're doing?
No, I'm looking for the Google Drive that you said.
Oh, yeah. Oh, okay. Okay, right.
Wait, but I realize XY, you don't have the length.
I'm doing this Swiss Cottage SA2 2015.
Wait, I realized that XY has no length.
I'm sorry, Kirana. It's me muted lah. I was saying something, then I forget. Sorry. Kirana,
I realize.
are you? Yes, I know. Yeah, I hear you. I feel that you're being confused by the drawing. I feel. Could you please draw a separate triangle that you want to do?
Okay.
So Arya, just now I commented my mistake and I was muted. I think Swiss cottage is a good choice.
Yeah.
Now, when you're doing stuff, obviously we cannot consult too much, but I feel that when you face a problem, you should immediately put it in the Jamboard. Okay. Right now, I cannot follow you, lah. Right? You realize that, yeah? I cannot follow you, right?
Yeah, I'll just take screenshots of the questions I'm doing and I'll put it on the chat board.
Fair enough. Okay, Kirana, this is our situation, right? I agree with you, and you know that you want the YQ, right? You know that.
Yeah.
So I really need this, right? You are correct. Your thinking is all correct. What is a bit lacking is that you don't realize how part one is helping you, and I'm already helping you also. So I cannot help you more. I'm already helping you a lot. Look at part one, look at what I wrote. Kirana, are you stuck?
Uh,
You're stuck, Kirana. Kirana, again, I assume that you're stuck here. Let's not wait too long. Okay, you need to do more questions. Right? Now, in part one, they ask you to find PR, correct?
yeah.
Okay. In fact, they don't say PR, they say polar. I mean, they say that pole is PR. So you finally do it.
Mm.
That's a hint. He's asking you for part one so that you can do part two. Do you see any connection? It's a yes or no thing. Yes or no?
Yeah.
Sorry, yes or no? Sorry, you see the connection? No? Yes or no?
Mm.
Kirana, if no, say no. Count.
Not really.
Okay. Now, more hints. Yeah. He said that the pole slides. Can you imagine that? The pole slides down.
Yeah.
When a pole slides down, does it become shorter?
Like, you mean the height?
No, I mean the whole pole. When the question say a straight pole PR is leaning against a vertical wall MQ, does this make any sense to you?
Yeah.
The pole sliding down, does it mean anything to you? No, say no, Kirana. Come. We cannot wait too long. Yes or no?
Yeah.
Okay, then the question remains, yeah, when the pole slides down, the length of the pole stays the same or does it change?
It stays the same.
I believe so. I believe that the pole also doesn't reduce. It makes sense, right? That's what happens, right?
Yeah.
Makes sense. Do you get the hint? Yes or no?
Um, Wait, is yx the same length as PR?
Why? We need a reason, right? We need a reason. Because PR is the pole, right? PR is the pole. And as the pole slides down, the P becomes X, right? The P becomes X. So the pole becomes what? The pole did not become XR, right? That doesn't make sense, right? The pole becomes what?
The pole become yx.
Does that make sense? That is now the new pole. Still the same length, but it's the same pole.
Yeah.
If that's the case, can you solve the question? Hurry up, I can see what you're doing so far, yeah?
Yeah.
What is that for? Why is it 4? Sorry, 4n and then minus, sorry,
So it's not
3.
4n. It's not 4n. It's not 4n. It's
Be careful, no? I don't see any rainbow, no? So yeah, okay, 3n, yeah. So minus 2, okay. Have you checked 3? I teach you that, right? You must check 3. Check n1, and 2, and 3.
when you reach it, when you bring the sides around. The rainbow is 3, right? So it has to be 3 and minus 2 for the first one.
I mean, if you test the first one, you're correct, right? You put in n equals to 1, your answer is 1, correct?
Yeah,
Correct.
wait. And then 3 times 3 is 9. Oh, wait, no, it's correct. It's correct. It's correct.
Yeah,
3
yeah.
minus 2 is correct.
Correct. Yeah.
Yeah,
After you
so-
test 3 things, then you are safe. Correct. Then you know that you're correct. Good for you. Okay. Progress so far. Yeah, just a bit rusty. Now, part C. Part C should be easy now. Lah.
Okay, it's 88.
Looks good to me. Okay. Hopefully you're correct, Aryan. You're correct. A good choice for a first question. Check the answer key. Yeah? Okay, Arya, next question. Yeah. Kirana,
Yeah,
how
I'm
is it?
looking.
Oh yeah,
Okay.
that's an answer. The answer's correct.
How do you feel, Kirana? Are you back to Pythagoras?
Yeah.
Not an easy question, definitely. Not something that you have done before, also definitely not.
Mm.
But I was trying very hard not to tell you the way to do it. I'm just giving you a hint. You realize that I think you kind of figured it out yourself.
Yeah.
Good for you. I hope with this, you're back to your previous Pythagoras, and hopefully we can try to do the next question.
Okay.
Shall we? Yeah, okay, good job. Okay, my advice to question 11 is again to focus on the triangle that you want, really. And to make sure you can draw the triangle separately first. That is usually comforting one. The reason why I'm suggesting drawing triangle because it is usually comforting, clarifying, make things clear, all good stuff in difficult question, right?
Okay.
Arya, okay? Any next question? Mhm.
Yeah, I'm taking a screenshot.
A polygon question. How interesting. Good. Very interesting. Interesting choice. Interesting choice. Okay, Kirana, have you decided on the triangle to focus on?
Probably FGH.
Okay. If you're confused, my suggestion stays the same. Yeah, seek comfort in drawing it. Good. Label it, where's the 90 degree, yada yada, all routine stuff, right? It will make you feel better. That's important in doing difficult question, right? Doing what you can, right? This you can do. And you put in things that is given, which is excellent, and your answer is 36, Arya. Okay, let me confirm. Okay, let me confirm, Arya. Which one is 72? Let me confirm that for what?
Which one is 72?
Yeah, this guy. Yeah, let me just confirm that, please.
This one.
Who is 72? Wonderful. Yeah, okay, you're correct.
Yay.
Your answer is correct. Wonderful. Okay, you use a reasonable shortcut. You use the what do you call it? The outer angle, right? Not the inner one. Good. Good. Very good.
How do we convert cause got algebra inside?
Correct. So this is maybe your first combination between Pythagoras and algebra. So that's the new thing, Kirana, yeah? You would notice that there's nothing that you know, right?
Yeah.
You don't have G or GH. So that is a little bit disturbing. I agree. But also please notice one weird thing that usually they'll tell you two things somehow, right? You have two things, and the last thing you're supposed to find. Now here, they actually tell you three things, which is very rare. Obviously, usually they won't tell you three things. If they tell you three things, nothing left to find much.
Mm.
So in this case, they are telling you more than necessary.
Yeah.
So it seems, so it's weird. At the same time, they're not telling you full. None of them are fully known. So that's a bit disturbing. So let me tell you something. They have told you enough. They should be telling you these three things because even as they tell you three things, there is always one unknown. The unknown will be the X, the algebra.
Mm.
Okay. Now what this means is that you just write down the Pythagoras. You will be able to solve for X. Have no doubt. Try to write the Pythagoras. Try to write the Pythagoras. Pythagoras is something that you can do anyway, right? So even if you feel that something is weird like this, okay, what? But maybe I should just try my Pythagoras for now. Okay, we can think like that one, even in exam. Okay, so you write that down, and then you write down the FA square, right? FA square is actually something.
So like bracket x plus 1.
Except for the fact that I think your FH is wrong. Okay, look at the triangle again. Look at the triangle again. Look at the question again. I think you kind of label it wrongly.
Oh.
So just to fix that, and then you can do what you said. Next question, okay, Arya?
Sorry, I'm lagging. Are you saying something?
Yeah. Next question.
Yeah, okay. I'm going to the toilet for a bit. I'll be right back.
Okay, do come back. Okay, Kirana, wait, stop, Kirana. Okay, stop. If quadratic is this easy, then you don't have to learn quadratic in term 1, term 2. It was quite difficult. Okay.
Oh.
Remember your quadratic one more time, right? If this is this easy, then no need to learn much. It's not that easy. Okay. Try again. So use what?
Do I erase your?
No, keep your mistake. And yes, this is a good revision. Oh, you're going to do the rainbow set. Okay, fine. Okay. You need a lot of space here, so take time. Okay, I'll make the drawing a bit smaller also. This is smaller, keep more space. Kirana, while you're doing this, I'll be checking something here.
Okay, I'm back.
Got it. I'm also back. Kirana, all that you did is correct currently, right? Arya, at least do one more question here. A ratio question. Right. Let's see how you handle this. Oh, Kirana, you forgot something. Sorry. Yeah, there you go. Good. Arya, just one question here. Just one question. This can be done using a primary 6 method, like even primary 5 maybe, right? Maybe. It can also be done using algebra from secondary 1. So I'm just curious about your preference. Do you want to go back to your primary methods or do you want to do the secondary method? That's up to you.
The algebra one is extremely easy.
Then you do whatever you want first. Let's see how you do.
Not sure how to continue after this.
Right. So Kirana, do you remember that sometimes we'll be doing not the shoe method, sorry, the cross method, right?
Yeah.
There's a cross method. There's also the cross method once. So for the cross method to work, this is your revision. It must be something equal to 0.
Yeah.
Now, in this case, this is not equal to 0. Now, you must make effort to make it equal to 0. Am I making any sense right now?
So the FH square equals also wait.
No, stop.
I need
Stop. The thing is this, you're not trying to find FH, HG, or FG. You're not. You're not. You're just trying to find X first And then we'll see what happened. Because right now in front of you, you no longer have FH, FG, and HG. It's just something, whatever X. Make sense? Now, if you could find X first, my question to you is, can you use X to find whatever you want? If you have X, does it help you?
Yeah.
Okay, I'm done.
Okay, good, Aryav. You check, you do the rest first, I'll check. Then why do you focus on finding X first, Kirana? Which means you have to do your cross method, right? Which means you need something equal to 0.
Wait.
Yes.
I need to add up the ones behind the equal sign.
You can do that first. You can do that. That might make it easier. Sure, you can do that. Do that. That's why you need a bit more space. Later, you can just move to the left. Yeah. Okay, good, Arya. Okay, maybe one more. Maybe one. This is my first time seeing you do a lot of topics. Okay. Generally, I agree with what you. And all right. Okay.
I'm done with the paper.
There is no more, really.
Yeah.
Henry gained 12, Beatrice lost 2. Yeah, good. Yeah, this not difficult. Whatever. It's not even a primary 6 question. It's like a primary 5. Okay. Really good. I'm gonna just look at the what do you call it? Swiss cottage, right?
Yeah.
Cottage. Wait, cannot be, right? Cannot be that there is no graph question. First of all, cannot be. I'm very curious about the graph part. Cannot. Would you kindly check one more time, Arias? Are you sure there's no paper 1, paper 2, for example, like that? There is no way there's no graph question. No way, no way, no way. Question 8, Arya, are you sure that's not a graph question? It's something else, is it? That's not the graph that you need. Question 8. Just pasting it there.
1 second.
Mhm.
I'm typing.
Hey, you missed the percentage question. Before you claim that it is easy, please do that first.
Yeah, I'm putting the questions inside the Jamboard.
Yeah, I'm pasting some inside the Jamboard. Okay? These two,
Okay,
just to
I'll do the
confirm.
percentage question first.
Okay. Okay, Kirana. Oh, Kirana. Oh, yeah. Kirana, sorry. Let me stop you for a while, Kirana. Sorry. Nothing wrong with what you're doing, yeah. But Kirana, this cross method gets harder when because of this 6. This 6 makes it harder. Right? Can be -3 -2x. Frankly speaking, it can also be 6 and 1. Correct, Kirana? There's a lot of combination because of this 6 guy. So this 6 guy is terrible, so to speak. Okay. That's okay, Arya. Okay. How about the question 8? Now, if we simplify. That means we don't want to have 6 here. At the best, we can try to make it smaller. I mean, if you found your answer, already good for you, lah. If you could find the answer. So what is the answer? I mean, I won't stop you, lah. So Arya, is question 8 the graph question or is it not?
What?
Cannot hear you.
Sorry, I'm lagging.
Okay, equals to 0, Kirana. Equals to 0. Okay, Kakak Brian and Kyoko, can you both hear me?
Yeah.
Okay, Kyoko.
Yeah.
Okay, got it. Kyoko, tell me, how are you right now?
Okay.
Okay. What shall we do today?
The area and the graph.
So continuing the school life, right?
Yeah.
Okay. Tell me, Friday also no school, right? Friday no school, right? Oh yeah, I remember already. Yeah, there's not going to be any progress, right? Okay, yeah, I understand. So no updates lah. Am I correct?
Yeah.
Okay. Did the event end up making you very tired?
No.
Clear, yeah. So, okay, please continue your area under the graph with Kakak Brian. And I think you should also finish at least the last kinematics on Kakak Brian.
Oh, okay.
Yeah, so we're just trying to keep up with the class and also get slightly ahead. Okay, for Kakak Brian, okay, very good, Kyoko. For Kakak Brian, Elliot is coming slightly late, so I'll send him in later.
Okay.
So let me.
Okay, I'm done.
Okay. Parallelogram. Wait just a minute.
It's either a parallelogram or trapezium. Because I'm not sure if this is. Yeah, okay, but no, it's a trapezium.
Okay, Daniel, I can see you. Okay. We'll correct it next time, Arya. Okay? I'll see you on Tuesday. Yeah.
Okay, bye.
Same thing with you, Kirana. Okay, bye, Arya. Okay? Same thing with you, Kirana. Yeah. I think we have to end here. I'll see you on Tuesday lah to catch up with the rest. Okay. Okay. As you can tell, this is a difficult question, and it is good that you're revising the algebra. We end up doing more algebra than Pythagoras. Correct?
Yeah.
So it's not a Pythagoras question. Mainly, it's an algebra question. If you can finish it, finish it. If not, we'll do it on Tuesday. Okay?
Okay.
Okay, see you then. Okay, bye-bye. Okay, Daniel, I can see you. Can you hear me?
Hello.
Yes, Daniel, I can see you. Can you hear me? Can you hear me?
Yep.
Can you hear? Oh, okay, right. Okay, so Daniel, what are we doing today?
Physics. I did a physics
Physics.
paper. Just
Physics
now.
is physics.
So,
Okay, so
I need to
physics free
share.
Jamboard.
Yeah.
Can
Can I
you
just share my
also
screen
can?
with you? Yeah,
Can,
a bit
can.
easier.
But I still have, wait, maybe I can annotate. We'll see what happens, right?
Yeah.
Okay, I can. Okay. So I'm gonna stop my screen sharing. There you go. Now you can speak.
Yep. All right, we should be good to go.
So if we need to, we'll go to the Jamboard. If not, hopefully this is good. I am only seeing, I'm not seeing any question. I'm seeing your screen though. Okay, great. If you could make it bigger and also allow annotation, that, oh, same problem lah. You cannot annotate, right? So in the end, I just have to go to the Jamboard. Okay, Ainesh. All right. Ainesh, good to see you. Quite early today, yeah. Please go to the Jamboard.
Yeah.
Oh. Based on the video also first. Right? Oh. Sorry, what is your question, Daniel?
How do I explain the random errors? So this part.
Yeah, and then errors also. Okay, so to keep it out.
Because
So,
systematic error says the best fit line does not pass through origin. Just here.
I think so. For the random error, it's quite simple. This is a best fit line, right? So there will be some values above and under the best fit line. Right? It's not exact. The best fit. Wait, we have to. There's nothing else here. I use the word variation and everything forward. Right. The random errors are the vertical, right? The vertical distance between the plot, between the plot points and the best fit line. That is, wait, whether there are, yeah, there are random errors which are the vertical distance between the plot points and the best fit line. Does that make some sense? Okay.
What are we doing today?
It's math, Alish. Confirm already. Math.
The circles.
Let's go. Yeah, we have finished. No, we have. Let's go. But an update would be nice. An update would be nice.
There's no update. I don't think I've had school since I last met you.
So like Wednesday and sorry, Thursday and Friday, no lessons.
There was school on Friday, but we just did probability.
Probably. Oh, probably.
Oh yeah, and for chem, I had a 1-hour consultation with my teacher, and he ran through speed of reaction.
Okay, good. Then.
Yeah, nothing else.
Is that a good thing for you?
Yeah, that's a good thing.
What? Wonderful. Okay,
like the consultation is a good thing.
Wonderful. If you can get more, I think that would be very helpful.
More circle questions.
Oh, no. The consultation seems good for you, right? Your connection is a little bit patchy today, yeah, and the Jamboard is also loading very slowly. I believe you chose the answer key question, yeah, Daniel. Okay, that's fine.
Yeah, I don't have the part 3 of this question. Approximate the length of the compound microscope.
Oh, this is the
Yeah, just give this for
yeah.
context.
You gotta show me the question. You gotta show me the question.
So this is part.
Okay, stop there. I can take a picture. I'm going to do something to the Jamboard. Please show me another question. So, Inesh, in the page, you have the correct page. Page 5. Page 5. Oh, wait, page 5. Yeah, we're in the middle of finding C1. Okay, so Inesh, would you please give me C1? Back then, we already found the very lightly
found it.
center point.
No, I
Okay,
remember I found
then write down. Then we can do the second part. Okay, so
Okay.
Daniel, if you could give me another question first, I'll be doing this compound first. I just copy that. Approximately. What would he need approximately? Next question will be nice, Daniel. I'll be doing this question in the gym.
These 3.
Yeah, I really need the question. Yeah. Question. To yeah, the bigger, or just like that. Okay, understand. Sure, the graph seems nice. Okay. So Inesh, where's the equation of the circle? Next page, please. Yeah. The question would be here. Oh, this is medical imaging, isn't it, Daniel? This is the topic medical imaging, channel 1. Okay. Now, what is your question on part 1? Because the X coefficient seems correct though. Seems correct. This one is correct. What's your problem?
I don't know what's going on.
This X half is like it's very similar to the half-life. It's not half-life, of course, but it's very similar to the half-life in the radiation thing, the decay thing. But meaning is the distance where you finally have half life. Back then, half-life means the time that you finally get half of the original material. Am I making any sense?
Yep.
So this distance x half is the distance where you finally get half of the original thing, right? Of the original thing. So where is it? Where is that half? Yeah. Can you find it in this graph? Because they give you this graph. Oh goodness, you already have half value thickness. So this is your x half. So your problem is reading the graph. Am I correct?
Yeah.
Okay, then what we do is this. So why don't we just power E everything? That help you? No, I just showed you that. Right? So if Ainesh, I'm waiting for the C1, you know.
Yeah.
Right. So the original graph, if they don't give you a lon by in terms of intensity only, it'll be something like this. So it's a matter of finding where is the half, something like that. Okay. Since this is ln I, one of the things that you can do if you're short of how to do it is to simply return it to I. So we will it take long? Too long. Like maybe. Maybe. Okay, let's think about it this way. So originally, this is e to the power of 4 because if you ln it, it just becomes 4. Does it make some sense? This number 4 is actually e to the power of 4. Would that be okay? Are you okay, Daniel? You seem very, sleepy. You okay? You sure? I'm drawing on the Jamboard. Yeah, you okay? You sure?
Yeah.
You sure? Right. You might want to just, release your node. Yeah, you might just want to do that. Okay. Okay. In the e to the power 4, this is the original guy because, never mind. Do you get what I say? This is the original one. If I put it as intensity, not just ln I, then I'll put this as e to the power 4. Am I making any sense?
Okay.
You sure, Daniel? You sure, yeah? Okay, e to the power 4. So if I start from here, then I just want half of e to the power 4. If I can get half of e to the power 4, then I can get my half distance quite easily. Half value thickness, something like that. Will that be okay so far?
Yeah.
Yeah, so half of e to the power 4 is not 2. Definitely not. Too bad. It's not 2. That's what I'm talking about. If that is the answer, that would be quite easy. Unfortunately, I don't think so.
Okay.
Because we're halving e to the power 4.
Copied the answer sheet and basically just told me that since we know it was just basically just said the mu is equal to gradient. Like no explanation. I don't know how they got from mu to gradient.
Now, I can tell you that, or I can show you the other methods of that. Well, I mean, wait, let me think. Which one is the easier one?
Just explain that to me.
What the connection is very bad. Oh dear. Your connection is very bad. Sorry, Daniel, the connection is very bad. I cannot hear you very well just now.
I think it's you.
Oh dear. Yeah. I can hear you speak, but I cannot hear you very well. Can you hear me well?
Hello.
Yes.
Can you hear me?
I can hear you kind of. I cannot hear you very well.
Okay, apologies.
No, it might not be. It might be the whole connection. It might not be us. It might not be both of us.
Okay. Yes, my
That's
screen sharing back.
right.
Oh, interesting.
Your screen sharing is yeah. I did know something, right? So yeah, Ainesh, the circle thing, like it's taking quite some time here, right? So do you recognize this? Do you you recognize the formula of Daniel?
Yeah.
Okay, if that is the formula, then if you recognize the formula, then I think it's going to be quite easy to explain. Okay. So, just a minute. So, Ainesh, you need to do you need to make this into the Pythagoras form? Okay? That's your challenge. That's your warm up. Okay, Ainesh?
Yeah.
Okay. Right. So, okay. So I confirm something. Okay, so now let me do this. Yeah? You want the intensity, right?
How do I bring this to Pythagoras?
The completing the square. Completing this. You should simplify first. Okay, remember your notes. Look at your notes. Yeah. Okay.
Wait, so what I did was wrong.
No, part 2, Edge. You're done with part 1. Part 2.
Okay. Yeah.
Yep, got it. Okay, I'm not sure whether I can explain to you or not properly, but it goes something like this. Okay, so then, and here,
What did you say?
this is the original formula that we have to work with. This is the original formula that we have to work with. Will this be okay? If you don't recognize this formula, then there's no way I can explain to you why this should be here. No.
This one?
Is that okay? Hey, sorry, Daniel. The formula.
The formula.
If you don't recognize this formula, then
No,
you can
which
just
formula are you talking about? I don't know this one that I'm circling.
Yeah, that one. I was circling that one and you circling. Yeah.
I can't see anything you're doing on the screen. Everything you do has like a 20-second delay. It's damn annoying because I don't know what you're talking about.
Yeah. Okay, so you know the formula, yeah? You know the formula, yeah?
Yes.
Okay, then I change the formula to suit this graph. This graph has very specific thing. This graph wants an x, and this graph wants a logarithm of the intensity. So the intensity that he wants is the I over the I naught. Okay. I'm jumping a step. So currently, this is just what I'm doing. So that'll be okay. Yeah, okay, there you go. It's changing already. Right.
Yep.
Now I'm changing the graph. I'm changing the formula to suit the graph. After this, then I launch both sides. Launch both sides. Okay. Then I will end up with logarithm I over I naught. Is what the graph wants, and then I'll end up with minus mu x. Okay. Would that be okay? This will be the x of the graph. This will be y of the graph. I have now adapted this formula into the graph that is presenting us. Would this be okay first so far? Elliot, I can see you. Can you hear me?
Yeah.
You'll be in a breakout room with Papa. That's okay. Kindly continue the CG question, and not sure whether it can be circled by at least CG. Okay.
Yeah.
Okay.
Okay. Now, if this is your y, this is your y-axis, and this is your x-axis, right? This is your x-axis, obviously. Then isn't this simply your gradient? I believe that's the explanation that you're trying to find out. There, the mu is the gradient of the graph. Correct. And that will be the explanation. If it doesn't make sense.
Is it because it's like y equals mx plus c?
Yes, the c here, definitely 0, and the c is not 0. Right?
Okay.
Done the factorizing.
Good, I actually look good. Now you draw that in the that model. You draw the two circles to the small side. And with that, that kind of answers a lot of things. Let's give you a try first.
Okay, the half value thickness formula I get.
Yeah, that is definitely a half value thickness formula, definitely. Right. And then you want the original intensity, right? Okay, good. Okay. We are back to that formula. You already wrote the formula, right? Okay, so I'm going to copy that into the next part, next page. So Ines, I'm just waiting for your Desmos drawing. Yeah? So to keep it, sorry. To keep it simple, the original intensity is simply when x is equal to 0, when there is no thickness. If that makes sense, I mean, wait, I think forward. No, it doesn't give you the I naught.
No, this is the wrong formula, I think. I don't think you can use this because there's no x.
What do you mean? The formula is correct. There is no other formula. But the x is there. The x is there, and the I is there. In fact, what you're looking for is the I naught, basically. I'm in the next page, sir. You go to the next page. So if I were to paste this here, right? So again, original intensity means when there is no thickness, if that makes sense, right? That's your x0. And when you're x0, you do have an I. The I is, the ln I is 4, right? the ln I as well. That's what you have from the graph. So far, so good. You're trying to find the I naught. Is it okay first? You have x, you have ln I, and you have to find I naught. Plus, you know the mu from the previous one, right? So you know a lot of things. Is this okay so far?
Yeah.
So my I is currently e to the power 4. Will this be okay? So we just put in e to the power 4 equals to I naught, which is what we're looking for. Then put in your mu, and it will be power 0. Oh, it doesn't matter. It doesn't matter. The mu doesn't matter. So e naught times 1, right? That's power 0, e to the power 4. I guess you have your E naught, I naught, sorry, I naught. I just shows the decimal so far.
I'm still doing.
Okay, so yeah, the next. Now in this page. Daniel, is that okay?
Stirred it.
Is that okay? I cannot hear you.
No, let me think about it.
All right, right.
Okay, so this is a mu. What's that?
That is no, that's a ln. Ln. From the graph, you got ln I. The graph is a ln. Logarithm natural. And like this logarithm I is this logarithm I. Yeah.
So you give x the value of 0.
Because that's what original intensity x of X-ray means when there is no thickness yet, when it hasn't, gone through anything. If that makes sense. I guess what about the decimals?
Almost done. There's a lot of stuff I need to keep. For the second circle, do I just calculate the center?
I thought you found the second circle.
Like the center of this. Oh, sorry, I forgot. Oh, yeah.
You found it, right? That's the whole point. That's the whole point. Looks good so far, Daniel. Right?
Yeah, please.
Okay, I'm looking at it. Oh, yeah, yeah. So this is a very good indication that your circle is correct, because C1 is touching C2, right? So far, so good, right? Very good indication.
Okay, correct.
So, okay, wonderful. So, Ainesh, it should not be difficult at all for you to find this distance. You please try that. That is just how we finish up the question.
Okay.
Your circle is in a good situation, right? Right. Well, let's see whether we can do it without decimals. But right now, we just do it with decimals. Just waiting for the next question. Then, oh,
You said you were doing.
let's see, oh, use something. Yeah, the microscope one. So the next question was right. So I just want to confirm something about compound. Oh, you have the focal length already.
Can show the.
Ainesh, write the Pythagoras in a third form, right? Don't make it in decimal. They don't like it. Okay. Now, simplify. So they are looking for this answer. I do. Look at the Jamboard here. Which is the third one. Daniel, I still have to confirm what's a compound microscope here. So please ask another question first.
Okay.
So,
where is it? Yeah, this whole thing.
okay, let me copy that. Okay, put me in the chat. So I wrote something, Ainesh. Does that make some sense?
Yeah, the three things I circled in green. Sure for me.
Oh, green lips. Let me circle that. Does this make any sense? Because you need to make a note on this one. So for Daniel, right? Nice. Oh, you have a question on pi. Progress, sure. This is your GP, this is your electric potential. That's fine. Voltage is called, right?
Okay. When I looked at this question, I didn't know what to do. So I copied the first step, which is this. How did I get this? And yeah, like from here I could do it.
Oh goodness me! Yeah, okay. This is like the single most important logic, and the logic that I keep asking to you. You have four things, right? You have the force, you have the field, right? You have the potential, and then you have the potential energy, right? Okay, so obviously there is no kinetic energy at the start, right? Obviously, right? Initial.
Yeah.
And then suddenly you have kinetic energy. You have to think very simple. So some other energy must be must be the one causing it. Some other energy must be changing from that something to kinetic energy. That's the logic. Make sense or not?
So increase in kinetic energy equals
Must be caused by
decrease in
the potential energy. It must be, right?
And potential
And
energy
there is a
is what?
potential difference. Your QV, in this case, it is QV, but back then I was asking you to remember there is a KQQ, right? QQ over R. Now this guy is
potential
KQR.
energy.
Potential energy
no,
is related to V by a simple Q.
Yeah, QQ over R.
That's
What's
why you
R?
can do it as QV. Then there's no R. Both are over R.
Yeah, where's the R in this equation?
There is no R. They give
Why?
you V, man. They give you V. V has a very close relationship with potential energy. The relationship is just 1 Q away. So
Okay.
QV is PE, potential energy, because they give you V here. Does this make any sense?
No.
But this is like the 5th time I told you, right? Now at this point, I don't want to ask whether it makes sense or not already. But I do need you to remember that potential energy and voltage are so close. It is separated by Q. Just like
Yes.
force and field is very close.
So there's no R lah. You don't even need to put R.
In this case, you don't bother with they call it the original function. You don't. In this question, because they give you V, you're very happy to take that V and convert it to potential energy just by Q, that potential energy. In this question, enough. That's all we need. Okay. The formula can be used maybe in other cases, like maybe you need it. Maybe.
So in this case, QV.
Yes, QV. Correct. It's enough.
Potential energy.
Potential energy. And potential energy convert to kinetic energy. The rest is history. That one you know already.
Potential energy, which is defined as KQQ over R, becomes
Yes, Peter.
QV.
Ainesh, are you okay or not?
Yeah, I'm
Ainesh,
looking
do
for
you
the
understand what I'm saying here?
I
Could you please make note first? This thing surprisingly they ask quite a lot, like this C1 touches C2 or not, kind of thing.
I already contacted that. I can make notes.
Are you sure that you don't want to write down in your notes? Are you sure?
I'll do it just in case.
Yeah, just in case, because we'll be reviewing this around 1 month. You want a very quick review. You don't want a slow review. You don't have much time. Write down in the notes. Write down in your notes.
Maybe after scripture, I'll make like a more comprehensive version that includes types of questions being asked.
Fine. Do more questions or circle up. That's fine. Do more. That's fine.
Yeah.
Once you run out, go to my Google Drive.
So just need to memorize E equals QV.
I phrase it very differently. Their relationship is very close, just like force and field, just separated by a Q, just separated by a Q. Just like the gravity one, separated by an M. But yes, at this point, just memorize what to do. Right?
KE equals QV.
Would that should be enough for part A, yeah? Okay, now part B then. The articles traveling, yeah, for sure, nice. Nice, very nice. Okay, right. So the electric field between the plates, right? Okay, so he wants the field now, right? He wants for part 1, for B part, he wants the field, and I believe he's giving you the voltage. So this is a test between the relationship of field and voltage. Would that be okay so far? In a parallel plate, things become extremely easy. If you want to memorize this, go ahead. Only in parallel plate, it becomes extremely easy. Okay, it is simply just what is written here. The E, the field, field will be equal to the voltage divided by the D. If you want to somehow see why the field is KQ over R square, this guy needs another distance here to become R squared. I'm totally simplifying it. You cannot just do this, but in parallel plate you cannot. So this is over R is over R squared. So it makes sense that the formula for parallel plate looks like this, but only for parallel plate.
Okay.
Would that be okay? Only for parallel
realized
plate.
I have the formula in my formula booklet. No, I wrote it
You
down.
should.
This is only for
you should.
parallel plates.
If there's a node, then tengah lah, tengah, because we cannot apply it else.
Equals V over G. Okay, then the last part.
So the time should, you got the time. If you get the time, why can't you get, okay, that's a bit weird. Now, did you find the time? So do you?
Or not? Because I said that it will not hit. I was just guessing about the answer says it will hit.
Well, I mean, to be fair, it's 3 marks, right? So we probably cannot just guess, but the time is already, wait. How come your time is correct and this is wrong? Let me think forward. Midway, okay, I was trying to find this as a midway answer. Right? So let me confirm what's the problem here. So for example, did you notice that the midway means the particle, first of all, will be traveling, alpha particle is positive. So it'll be traveling to the negative side. Right? So it'll be dropping towards the negative plate. The negative plate, in this case, will be the 0 volt one. Am I making any sense right now? Okay, this is your electric force. So you only have clearance of 0.4 centimeter. Is that okay so far?
Yeah.
Then this is your distance law, and then you use Suvet law. You use Suvet. In this case, it will be SU plus half A T square. Right? Am I making any sense right now? I'm giving you the pairs of it. You're going to Suvet this guy with the acceleration that you have. The distance to cover is 0.4. The time that you have, you already have the time. Surprisingly, you have the time.
Why is it surprising?
Can it be difficult? Am I reading this question wrong? The time is usually difficult. But you have the time. So the Suvet is totally available for you. You have the T, you have the A, you have the initial velocity, and you can just calculate whether you'll cover the distance of 0.4. Am I making any sense?
So my S should be less than 0.4, then it won't hit.
Yes. If it is more, then it will. Now you should do this because 3 marks, I think they definitely expect this. Might as well revise your Suvet. I've never seen your Suvet before, right? Kinematics. Ainesh, I take it you have a question now?
Now I'm still looking for it.
Can we just go to my Google Drive? I mean, this is taking quite a lot of time.
Yeah, sure.
Okay. Go to my Google Drive. Just go to the local school. Are you doing it somewhere? You need to. This one a normal thing to use Suvet in as the end question, as the end question. So might as well get used to it. Let's see also that. Oh, I have the compounding. Okay.
It only appears in paper 2, right?
No, that's not true either. It can be in paper 1 and paper. It can be. Yeah, no, it's not. It's not. Yeah, just look at it. Yeah, it's 0, correct. Is it a square? You need a square for the time.
Oh. So it will hit.
I'm sorry, you're saying, Daniel?
It will hit.
It will hit. Is that the correct conclusion?
Yep.
It will hit. Oh, yeah, because the timing is lesser, right? Than wait. Oh, it travels more than that. Yeah, travels more. Yeah. I hope that makes sense. So Daniel, I'm still not getting the compound thingy one. Not yet. Please ask me another question.
Let me show you the answer.
Inish, can you get the?
Do you want to see the answer for the compound
yes.
question? Right.
And I'm not sure I will understand at this point. I'm not sure.
I have no clue what the question is.
Inish, have you gotten the question?
Maybe part 3.
What is 4? What is 4? What 4? No, that's
I think I found
5. Okay. That's 5. That's not 5. I'm sorry. That's 3. 3. Yeah. We just copied it. But I don't think I'll get it for now. Daniel, again, I owe you this. I will make sure to understand by tomorrow. Yeah, that's the latest. I don't think I get it. If you would ask another question for now.
Buy about $30 thing.
Oh, right. Okay, so Inish, time to learn something new. Your Desmos, please. Desmos, all this. Time to learn something new. Right?
Okay.
So Desmos, and then I'll start. Daniel, next question, please. I don't get the microscope. I'm still looking at it.
Okay.
Okay. Put it in decimals. Let me screenshot. Hello?
Yes, Ahish.
I
Decimals?
put it in decimals.
Okay. Yep. Okay. Daniel, do you have another question to ask?
Let me look through.
If not, then any new question, right? Okay, we should learn as much as we can, right?
This whole yeah, I don't really get this. Short one. Okay, question one. So I was under the impression that the electron will go from higher potential, which is here, to lower potential.
Higher to lower. Yeah. Well, I hope that makes sense because it's more like a going from positive to negative.
Yeah,
Naturally, this is
B.
naturally doing that. Naturally.
The correct
Okay,
answer
very
is
simple.
opposite
Very
direction.
simple. What do you call it? Wait. Okay, let me read the question first. Because I say that's naturally, right? There are always cases where it can climb up, right? So let me just check whether it can climb up. Okay, I get all the questions. Okay, I'm at page 18 here. Just me, what I'm talking about is an electron, right? Sorry, it's an electron, right? Yeah, electron. Okay, electron. Electron is negative. Right? Okay, so are you at the? Is the next page, Daniel? I wrote something already for you to do. That's an easy one.
Yeah.
Daniel, the next page, please. The next page.
Oh, sorry, yes.
Yeah. So since it's an electron, again, apologies. What am I talking about here? It was very stupid of me. So electron will approach the positive instead of the negative, right? Naturally, correct? Right. So you can feel it like the force of the electron the force on the electron will be attracting him to the positive side, lah. I mean, around something like that. Did that make sense? This is more positive and this is more negative, so to speak, right? Not making any sense, Daniel.
Yeah.
Then, I mean, because the option is quite clear, it cannot be A and cannot be C. It's not going to be B, lah. B is not going to be, electron is not going to be attracted to the negative side. Electron is going to be attracted to the positive side. Again, if the option is A, B, C, D, we should choose D. Right? Am I making any sense?
Yeah, but if it was like a proton, then it would be B.
B. Yes, yes, as simple as that. Solve it the opposite. Correct. Correct. Right. Yeah, correct. You have to watch it whether it's electron or proton. Right. Now, Ainesh, please tell me the midpoint. I don't see. Oh, the midpoint is there.
So,
So,
could you just say
Ainesh,
oh, sorry.
you're saying, Daniel? Sorry.
Can I just say in general, current will always flow from positive to negative, or higher potential to low potential? Can I phrase that?
Current,
Or what is the arrow
current will.
presenting?
You mean the arrow D? Yeah? The arrow D.
No, what does
Which
what does this arrow
which-
represent?
Which arrow? Sorry, which arrow are you talking about? Sorry.
The one I'm circling.
That is your arrow, right? Am I correct? That's your
Yeah,
arrow.
but
Yeah?
does it represent anything?
If you want, it represents the travel path, right? The travel path of a proton here. It represents that if you want. A proton will travel at this path, starting from here. I'm so sorry. Starting from here to here. That makes sense? That's one way to put it.
Hmm.
Finish. Paste the next part of the question first. Sorry, the equation is not complete. Paste the next part of the question first in the next page.
Can we do D part 2? Down here.
Finish. Please paste the next part. Is it? Okay, Daniel, I think I need to see the diagram. There seems to be some sort of picture. Wonderful. And then okay. So Ainesh first, yeah. Ainesh, you're looking at the page 8, right? Ainesh, don't be muted, Ainesh. We need to communicate.
Hello? Can you hear me?
Right. Okay. Yeah, Ainesh, right. So I'm asking you to skip to part 2 first, yeah. The radius explanation I'll have to explain when we are looking. Okay. It takes some, there's a jump in difficulty. Let's just put it that way, yeah. Jump difficulty. Right. But for the center point, can you follow that? It's definitely something, comma 1. Am I making any sense? Because of your midpoint.
Oh, I remember we did this last time. Yeah.
It's a little bit new, so this is a big jump, right? So that's why I cannot explain directly. But it's
Hello?
definitely the Y we know, right? Can you hear me? The Y we definitely know. The X we don't know. Can?
I think I'm lagging out. Yeah.
No problem. Anish, can you hear me? Can?
Yeah. Your voice keeps
okay.
breaking.
Okay. So one more time, we know the y of the center, but we don't know the x of the center. Can? Can? Anish, can you hear me?
Yeah.
Okay. So
So
use the r. Can you hear me?
Yeah, so basically I use r equals 10 to find the center.
The x of the center, the y you know already. Okay. Once you do that, everything is easy. You just do part 4 first. Okay. Right, Daniel. I promise to explain the part 1 as a jump.
Okay, so but I thought that's not how you're supposed to do proof questions.
No, we haven't proven that the radius is. We haven't done that. We are just using the proof question for part 2, part 3, part 2 and part 3. Okay, we're just doing that. You okay, Anish? Anish, would that be okay? Are you lagging?
Oh, I'm lagging out a lot. I'm gonna leave and rejoin. I can't even hear what you're saying.
So Daniel, is our leg that bad? Can you hear me? Can you hear me, Daniel? Is our leg that is bad?
Yeah.
Okay, I'm looking at the Jamboard right now. Correct. Okay, Daniel, let me confirm that you're asking D part 2, correct?
Yeah, correct.
Oh, D part 2 is definitely not needing the EMF 1. Okay, easy. So energy dissipated. So this joule will be equal to the Q, will be equal to the MC delta T. That's your C. That's your M. That's your Q. It's just QMC delta T. Okay. Nothing complicated. Do you understand? You did everything. You did all the hardest part. This is actually the easy part. Does this make some sense?
Okay.
I mean, good job lah. The hardest part you can do. Anish, I did type something. Please don't wait for me. I can still follow your video, right? Okay. Okay. Please don't be muted. Can you hear me? Please don't be muted. Can you hear me?
That's Q.
What's Q?
I did write down in the Jamboard. I did. You didn't realize the connection with part 1. Part
Why
1
is it
gives
so
you that.
small? 0.13 joules.
Yeah, I mean it's fine. It's fine. The mass of the wire is very small also, so I don't think there's any harm. That's very small, but yeah, I don't know.
Okay.
Oh, got the next question. I understood. Ainesh, are you saying that you are done with that one? Ainesh, are you saying that you're done? Never mind. Oh, okay. Daniel, would you tell me what the question is, right? Daniel, tell me what your problem is.
We just go through it together.
Okay. Oh,
I haven't
for
attempted it yet.
One, right? Okay. Oh, right. Okay. Oh, right. The force affecting P will be what? Tell me.
What?
Force affecting P will be?
I mean P. Oh,
Affecting P
gravity.
will be- Yeah, wait lah. Q also, yeah. Now, obviously, Q is, gonna be here, and then suddenly Q may have another force. See lah. Do we have another force, right? Is there another force going on? Right. So let me just, yeah, okay. Okay, right. So, let me clarify one thing first, Daniel. Yeah, there is no current here, okay? But the ball is falling through a magnetic field. The ball is falling through a magnetic field, and the ball definitely will slow down. Definitely will slow down. Do you know this or not? That means, is it inside your brain or your?
No.
Okay, then let me just explain.
Yeah, I know it'll take longer because the questions are. Is it
That's
because
what I mean.
the ball will be attracted to the magnet?
Well, surprisingly, no, because it's aluminium. So that's not the answer, right? It's aluminium, so it's not magnetic in that sense. You also need to know that. Also need to know it. Let me confirm one thing. Right. The answer is something. No, it's something that you know already. It's the FBI thingy. It's still the FBI.
It will induce a current.
Will induce a current. Yes, the magnetic field will induce current on the ball, blah blah, and the current will the ball will definitely slow down not because of Lenz law. They actually give you the hint of it. That is the correct
inducing a
thinking lah.
current. Wait, how will inducing a
Okay.
current cause it to slow down? Because the force will be directed in.
Because every time, maybe I'll put it as a very general, because every time something have induced current, the Lenz law always say, okay, it's gonna, induce the current in a way that opposes the inducing motion, right?
Yeah.
Right. So if the inducing motion is a drop down, the drop down will be slower. It makes total sense, Daniel, because this is kinetic energy converting to electrical energy. The kinetic energy must reduce. Then you get electrical energy. It totally makes sense.
Aluminum will gain a charge.
Not a charge, no. A moving charge, a current. You will have an induced current. Aluminum will not gain charge. It will gain the movement of charge. Again, current. For these 4 marks, if you can just accept that when the aluminum falls through, cuts through the magnetic field, right? You will have a change in flux. Change in flux will induce current. Induced current will, by Lenz law, blah 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 blah. Same with P. You have 4 marks. Am I making any sense? Ainesh, are you stuck? Ainesh, tell me. Can you hear me, Ainesh? Are you stuck? Please be unmuted. Okay. Would that be okay, Daniel? Or oh, we run out of pages. Let me create one more for you first. I'll delete this slide first. Okay, there's one more page for you. Next page, Ainesh. Daniel, are you okay? Are you okay, Daniel? Sorry. Daniel, are we okay with this question, or do you want?
Yeah. Just give me a sec.
Okay.
I think some money issues.
Ainesh, do move to the next page, please. That's the easy. Yeah, that's the easy part. Yeah, so Ainesh, at this point, that's like a bonus question for you, like it's just bonus 2 marks, right? Even locals have bonus.
Okay. I'm back. So
Yeah. Would you like to do this question or would you like to do a new one?
as Q falls, I'll do this.
And let's just kindly check the answer key first before doing part 4 lah. Wonderful, Ainesh. Just close your make your Jamboard small, Daniel, easier for you also. I can read also. Okay, you can read also. Yeah. So Daniel, in short, you should compare that with P, right? Just to close out the 1 mark, you should do that, right? And also, I believe you should mention like so I do have a additional thing. Okay, I'm just waiting for the decimals. Feel free to do one more, Daniel. Let's squeeze as many things as you can today. I owe you the compound and I will promise to talk about it tomorrow.
Hello, can you hear me now?
Yes, I can hear you now. Yes, I can hear you. Yes. How it is? Okay. Seems smooth now. Seems smooth now.
Now, and you're lagging still.
Okay, never mind. We just continue. So, do you have the Desmos? Just use typing.
I'm so sorry, I cannot hear anything you're saying.
Let's type. Let's just type Desmos now.
Yeah.
Okay, oh, here's a new question. Daniel, tell me what is what is your problem here?
Yeah, I'm done with everything already.
Do you have a question on? Oh, question 5 is okay.
Already. I'm just waiting for
One.
your opinion.
Oh, wonderful, wonderful. Yeah.
Magnifying.
Yeah, definitely. I want to. I owe you lah for tomorrow. For tomorrow, what should we do? Just
I
curious.
was planning on doing math tomorrow.
Math it is then.
I was just showing my
Okay.
schedule.
Mhm. Mhm. Ganesh, do we have Desmos? Ganesh?
Yeah, so tomorrow I'll be doing differential equations in the morning.
In the morning. Sorry. Is there a morning schedule? Oh, you. Sorry. Yeah, understood.
Yeah,
Understood. Wonderful.
So you see Monday, 10 to 11:30
Yeah.
DE.
Right.
I did a
You
bit
did
of
ask for.
vectors today also, so I'll catch you up on those also.
No problem. No problem. Let me confirm that you did request for Monday night, right? I didn't get it wrong. That's your request, right?
Oh, you said 12 to
Not
1:30.
Tuesday. Sorry. What?
Didn't you say 12 to 1:30 tomorrow?
12 to 1:30 tomorrow.
Yeah.
Oh, wait. If I say that, then certainly I will. But did I say that? Whoa. No. In the WhatsApp that I wrote, it's Monday either 7, 8:30 or 8:30, 10.
Both don't work.
Both doesn't work for you, sorry.
Yeah.
Oh, no. You say 8:30, like you say 8:30 to 10 works for you next Monday. Is it correct? Is it correct?
Yeah. That's 23rd June. Next
When-
Monday, yeah, that would be.
There'll be
Okay.
next Monday. Yeah. Are you okay? You sure? It's
Not
more
really.
like more.
I
You'll be
would rather
tired,
do
isn't it?
morning, yeah.
But morning you haven't done much, and I do have a schedule. Oh, cannot. Even if you want to, it's more like afternoon. That means
What time?
after 3 like that. After 3, no? If you really
Cannot.
want. You cannot. Or you're talking about morning or near lunch, I do have a schedule.
Okay.
But the Monday day is correct. Monday is correct.
Yep.
Okay, understood. Let's make the best out of it. Okay.
So what, 12 to 1:30, yeah?
No. I cannot. 12 to 1:30, I cannot. There is something going on there. I cannot.
What time can you do?
After 3, no? After 3. What, 3, 4, 5, 6, I guess that works.
3 to 4:30 works.
3 to 4:30. All right. 3 to 4:30. Okay.
Okay.
So that is not the night lah. So the night we don't meet. Am I correct? 3
Yeah,
to
night,
4:30.
night cannot.
No, 3 to 4. I'll see you then. Okay.
Alright.
Bye-bye.
Bye-bye.
So Ainesh, are we still lagging? Let me confirm. Are we still lagging?
I think you can hear me clearly, right?
I can. How about you?
But whenever you speak, it keeps breaking up because my internet is quite buggy.
Okay. So you need the C1. Anish, you need the C1 in the decimal.
Yeah, the
C1
circle.
in decimal. Yeah, C1 in decimals. C1.
As in C1 as in the circle.
I know you want to reflect the C1, ma. So at least draw the C1 in the decimals.
Oh,
I mean, it's easy. It's easier to see, ma. Easier, ma. Right.
Okay, I put it in.
Right. Okay, wonderful. This should be in your note. This is not the first time you reflect a line. So when I reflect a circle, when you reflect a circle, you don't reflect the circle. You reflect the what?
You were saying?
Never mind. Type.
Sorry.
Oke, Zira paling itu semuanya. Ziranya suruh oke, ya. Zira kalau
Okay, I'm done.
Yeah, I can see it, Anish. So the 3,0.
Comma 0. 3,10.
Hey, 10. Sorry, 10. Yeah.
I subbed it in and I got a value that's more than 100, which is inside the circle.
More or less?
More. But that means it's outside the circle. Sorry. Yeah, outside.
Outside. Okay, inside. So
Okay.
Okay.
What? It doesn't even say the answers.
Right.
Like it does,
310.
it does have the answers, but it's not the answers of the question.
But I am sure that it's outside. It's slightly bigger than 100, right?
Mm. I mean,
Yeah,
I
I
put in
am
the
sure it's
point.
outside. Yeah, I
And
agree. I mean, when I look at the decimals, it looks outside. It does look outside.
No, it's inside.
For now, so how? Are you okay? Are you satisfied with your answer?
I'm satisfied, but my answer is wrong.
What
I
do you
feel
mean
like
by
I
your
did a
answer is
big-
wrong?
I put the point in decimals and it's inside the circle.
Hey, you have to do the reflected circle first. Hello.
Oh,
You haven't done the reflected circle.
yeah.
Type the reflected circle, then you'll be correct. It's a good idea for you to check with decimals. Good, you get it.
Yeah, it's outside, but quite a bit. Actually.
Which is, that means your answer is 100 something, right? So it does reflect that a little bit.
Yeah.
Now, I'll explain the first one tomorrow.
Sure.
The first one requires a bit more. Okay, so good job on the circle. This is like, this is your first time not dealing with local questions. Okay.
Yeah.
I think you get it. I think you use decimals well. I wish that you're faster, but right now I'm okay. I like how you use decimals and like how you think. Let's focus on the positive things. Okay.
Just as a warning, right? The house has had some like internet issues, so I think tomorrow there will be like a bit of lagging and stuff. I'll try my best to fix it.
Fair, but tomorrow we'll be doing questions lah, like from the paper, correct or not?
I keep thinking Monday is okay, but yeah.
Yeah, no, your camp is done. Like we'll be doing questions like including OP, right? So tomorrow we'll focus on the question. Yep. Now, write your circle notes. Okay, we'll be using them on Thursday.
Thursday, sure.
Okay. Good job, Anish. I'll see you tomorrow.